Okay, test. That should be live. Let me see if Twitch has caught up. That looks okay. Okay, perfect. Hello everyone, welcome back to the compiler project. So first, before I begin going ham on the keyboard and writing some code, I want to start with apologizing. The last few weeks have been kind of lackluster between the missed streams and a lack of progress. I feel like on one hand, I shouldn't be apologizing because the reason was I was sick, and that's not something I can control, and therefore not something I should be apologizing for. On the other, I still feel like, yeah, I'm sorry, the stream hasn't been as like we haven't made as much progress, and it hasn't been as interesting as I would have liked. Now, on Tuesday, I was stuck. The stream on Tuesday was very short because I couldn't look at the screen without feeling like I was about to faint. So that was not very good to make a lot of progress. But it was interesting nonetheless because I was completely stuck on how to do the renaming phase of the analysis part of the compiler. As in, we look at all the names that appear in the code and we decide, okay, where does that name come from? Is that a local variable? Is it a function argument? Is that another function in another module? How do I represent the output of this phase? And I spent an hour being completely stuck. And I don't think it's bad for the project as a whole to have streams where we make no progress because, being stuck is part of the process. But I could not figure out why I was struggling so much. And I figured that today before the stream. And the reason why I was stuck is because a lot of my approach so far for this project has been to look at what GHC does and to make similar choices for like a good reason. GHC is a compiler written in Haskell. As a result, writing a compiler in Haskell, it makes sense to look at what already exists. But one thing I've made a mistake with is thinking that the same reasons would apply and the same logic would translate. And that's not true. For instance, GHT has this renaming, type checking, simplifier phases, and they are somewhat separate. But that's because the language GHC is trying to translate is Haskell, which is extremely different from the one we are trying to translate here, which is inspired by Rust. As a result, a lot of my questions on Tuesday about like how do we represent the result of finding the correct name of something was because I was trying to persist information that's very complicated to persist, basically scoping information, so that the type checker wouldn't have to redo all the scope analysis. Maybe I don't have to do the same thing as GHC. Maybe I should not be separating the name resolving and type checking phases. Maybe I can just do one big analysis phase that does both. And then suddenly, all of those problems of like how do I persist information between the phases completely goes away. And that was the key to unlocking a lot of the issues that like to figuring out a lot of the issues that had me blocked on Tuesday. So I think today we're gonna be able to make progress. But first, there's another thing I have figured out that had been bothering me for a long time, which was my use of this extremely verbose list of extension types for the AST. It started extremely verbose because my reasoning was this is the right shape for the solution. I don't know which ones of those I will need. Let's start by having all of them, and I will remove the ones I don't need when I start having a better idea of which representation I need. That was also a mistake. It turns out this isn't the right approach. I had been trying to avoid the higher kindred type approach where some parts of the AST are wrapped in a given functor that's given as an argument because it introduces some complexity with dealing with accessing values that are within a wrapper that is a functor. How do I deal with like not having a wrapper in some cases? That introduces some complexity that I was trying to avoid. But as a result, this was the wrong design choice. And I think today, the two things I want to try to achieve, I don't know how much time I'll be able to, like, I don't know how much time I'm going to be able to spend on each thing. I don't know if I'm going to finish everything today. What I want to do today is first get rid of all of those extension types in favor of something a lot I say simpler, a lot smaller at the very least. And then in a second phase, if we manage to fix this and then fix the parsing, the output of the parser, then move on to start the analysis phase, which is going to combine the name resolving, type checking, and so on. So yeah, let's get started. put myself back in the corner there. So the main thing I want to do is no longer have like parsed and renamed and simplified and like have all those faces. I think for now I just want to have parsed and resolved, pre-analysis, post-analysis. And there may be more phases down the line. I'm thinking maybe for conditional compilation, for incremental compilation, I might introduce a new phase like compiled, basically, that ignores all of the actual code and just keeps the top-level definitions and associates some bytecode to them or something. I'll figure that out when I get there. But the big thing is, instead of having all of those extension types, the thing I was thinking of doing was to instead have a notion of annotation around types within the AST. And the thing I was thinking was something along those lines. So an annotation is something that to a given inner type, which has any kind, I'll get back to that, and a given phase, which is an AST phase, what do we associate? We associate a type, which is the annotated type, which to K, to the inner and to the phase associates like some type that corresponds to how this should be wrapped at this given phase. And the reason why I'm using a polytype here, I've been thinking I could be just giving, expression or statement or something, but not all of them will necessarily be parametered by the phase type. So by leaving it as a polykind, I can give expression or something as long as I know how to construct a actual type from this. I can give any kind there. That's gonna work. The thing is, I'm going to need at some point to access things within that field, so I'm going to need to have also the inner type, or the wrap type, I guess, which is also the result of like what is the inner thing and the phase. And I will need to have a lens, something that allows me to access the actual value within the annotation, regardless of what the annotation is. And in the case of no annotation, it will just be a lens that's just like ID. So this is going to be... how do I name this? I don't want to name it inner because that's already the thing I'm using. Annotated? The thing that's inside? Within? Within is not the worst. And that's going to be a lens from annotated inner phase to wrapped inner phase. Okay. So what do I mean by this? And what I mean with this is I am planning to basically say how each thing of the AST should be annotated by declaring instances of that class. I'm also I should probably bundle constraints. I'm gonna do that later. What that's gonna look like is something like this. I think it works. I'm confident enough that this is correct Haskell. There might be some subtleties. I think I might need some undecidable instances for some of that stuff. We'll see. We'll figure that out when we get there. So the idea is this. The annotation of an expression after the past phase will be... So the annotated type of the expression during the past phase will be something like with location expression past. With location is something that doesn't exist, but it could just be a tuple of location something else. I'll see what I want to do with this. The wrapped type as in what is within, that is an expression past. And within, the lens that goes from one to the other is going to be, if this is just a tuple, this is going to be underscore 2, as in the second element of a tuple. Now, that's going to be more or less the same thing. I think I need to wrap declaration, statement, expression. I think that should be enough. I don't think there's anything else I need to wrap with like location information. Yeah, I think that's all. So that will be, I'm going to replace here expression by statement. Actually, I'm going to do them in the other order. And statement with declaration. And now we have to decide, okay, once something is resolved, I'm going to be no longer in the past phase. I hope this is still big enough. I've zoomed it out a tiny bit. If it's too small, let me know. I'll zoom it back. It's fine. So when we are resolved, what is going to be the annotation? And I think for now, it's fine to say it's no longer annotated. There is no longer a value there. So the annotated type and the wrapped type are the same. And therefore, for all of those, the lens is ID. I think this might not be true. I think this is like good enough to get started this evening, but I think this is not true. For instance, I think expressions will actually be something like with type or something like this, something that adds the type information to the resolved expression. And I also think that's not going to be enough in the sense that like we are still going to want to have some type families because I will want to have different types for like names, where at the moment I have identifiers as the output of a parse. Like, yeah, in this expression we're saying x plus 3. I will want the x to no longer be an identifier, but a proper name, whatever name ends up being. But I think instead of having, unless I keep this big class for the types like this, I might keep the class. I'm just gonna simplify a tiny bit. And by which I mean I'm gonna remove all of that. Okay. So that's a tiny bit less horribly verbose than what we had before. Now, we are gonna have to change our AST. That's fine. So I think the AST will continue to be the same structure, where we have just the parameter, which is the phase, that represents the state of the AST. That being said, I think this module type will only be relevant when we have finished parsing, because after resolving, the imports no longer matter. So I think maybe we'll have this type as being the parsed module, and we'll have a completely different type for the top level wrapper of the AST after resolving, rather than trying to make this fit both. Since it's the top level, it's going to be very easy to just like substitute one for the other. But for now, this is perfectly fine. This just means at some point, maybe this parameter will go away and module will just be like a type that is only for the parsed version. Import no changes. And I can also remove a lot of unnecessary white space here. And I'm just gonna call that name, even though that hasn't been defined yet. I tried on Tuesday and I was struggling because, again, I didn't have the right approach in mind. So with this, now we can change a few things. Now, none of those constructors have any of that nonsense. And instead, here in the module, I have, instead of having a declaration, Here I have an annotated declaration at this given phase, which will look at the given instance and will pick either a with location or no location at all in the case where we're done and the location information is no longer required. Okay, so that's a bunch of stuff removed, which means now a declaration no longer cares about where it appears. It doesn't contain that location or any other weird type anymore. It just contains the whole thing. The downside of removing this per field extension type is I am losing the ability to make some branches unrepresentable at some points in the different phases. If I had a lot of phases and some of them prune some of the branches, having an extension type to be able to say this is void, therefore this branch cannot happen, would allow me to basically prune the AST based on the phase, but that's not something I think we're gonna need. Now, we can continue doing this. I have already replaced with name type everywhere, where a name of a type or the name of something appears. This is no longer going to be enough. I'm probably going to have to introduce some kind of constraint that bundles everything I need. Next, for a struct, what do I have? Yes, that's fine. Here for const info, this is an expression, therefore that's something that's going to need to be wrapped, and as a result, that's just an annotated expression at the given phase. For the function, here, does function archetype require... Yes, it does, but it's already done. For the statement, those are going to be annotated statements. For the statements, I can there again remove all of those extension types that I no longer require. Annotated statement. Annotated expression. Actually... Yes, this is an annotated expression. This is an annotated expression. Here, annotated statements. And here, again, this is going to be a lot more readable. I can remove all of those extension types that were really a mistake. Good riddance. And however, for all of those, okay, there we go. So now our expression tree will be annotated at each level, which expression will contain the location at which it appears. However, once we are resolved, the expression tree will just be expressions and will no longer contain whatever wrapper we have, or again, will contain some type information, whatever we want to annotate the expression with. And I think it's better to do it that way rather than do it as an extra constructor that has to be defined for each constructor individually. Now that should be all, because path info is now specific to the past phase. I'm tempted to make a separate section in the file for the things that are specific to this phase and keep all of this as the generic regardless of phase stuff. I don't know. That can come. This kind of cleanup can come later. Now, none of this is going to compile. because all of the pretty printer, all of the pincer expect the old shape of the AST. So I think the next step is going to be rewriting a bunch of things. Plated is going to require the lens. It's going to require the within lens. That's fine. Can I always do a traverse? No. Hey, I'm using mostly the arrow keys. I've been meaning at some point to learn how to move without them, especially because I want to switch to a split keyboard in which I would not have, like, I don't want to move my hands too much. But yeah, I'm purely using page up, page down arrow keys. Extremely noob way to move around, but 20 years of muscle memory is hard to forget. Okay, so let me just quickly think about what I'm missing before I can try to compile all of this. All of this is going to be broken. I'm going to have to rewrite all of this, but that I know. I have the Moonlander, I think it's called. I've bought it at some point because like it looks absolutely fantastic, and I have never actually taken the time to learn how to use it. And I really want to because it looks fantastic and it's probably a lot better for my wrists long term. But it requires to learn how to type properly. And the problem I have is every time I try, I am so slow with it that unless I have all the time in the world to like get used to it, it feels so weird to have to think about typing that I haven't taken the time to actually learn. What I need to do is at some point take some vacation, not have anything that needs to be typed quickly, and just spend a week actually just learning how to use it. But I haven't done that yet. So let me just quickly think about what's missing. The parser is going to be broken. This is going to be broken. That I know. But is there anything else that's missing that I need to fix before I try to compile and see where everything is broken? I guess I need to define what with location is. Which is going to be for now. I think I've decided it's just a tuple of location and something, but I need to define that if it's not already defined. And I need to define name because I have it defined here as being the result of renamed. So I remember we had tried to have something on Tuesday and we failed miserably. For now, type name is gonna equal void string. That's completely wrong, but it's just so I can try to compile those changes to the AST at first. Now, for renaming, renaming is just gonna, I'm just gonna kill that file. It's no longer useful. None of it was worth keeping. Goodbye. And I need location. I don't have it here. Presentation, location. Do I have with location? I don't. But that's gonna be for now, unless I want to do something a bit more fancy at some later point. With location is a tuple of location and some value a. Okay, with all of that, we can probably... Actually, there are a few things I know are going to be broken, so I might as well try to fix them before just trying to compile and follow the errors one by one. Some of them are going to be the pretty printer and the lenses at the end. Because, for instance, if I look at, well, here, for instance, all of declaration and all of the others no longer have the argument I have to ignore, so I can fix that pretty quickly, pretty easily. Here, likewise. This is a bit too big to fit on one screen. I could do something. Give me 1 sec, I'm just gonna do this one. Actually, now it fits. One more reason to get rid of it. That was expression, I did statement, and declaration. Perfect. Okay, now where this is going to be wrong is every time in one of those I have a statement or something. Now it's no longer going to be directly that thing, it's going to be the wrapped thing. So I'm going to need to get the thing that is within. So here, for instance, map pretty something, I am going to need to I guess I could not try to like handle this by explicitly unwrapping, but since I know all of the wrappers that are gonna exist, I guess I could say that if some type A has an instance of pretty, then there is an instance of pretty for with location A, where pretty is just pretty second. And that way, I think I don't have to handle anything specifically. This pretty on a with location declaration will delegate to this instance that delegates to then the pretty instance of the declaration. And in the case where we no longer have a wrapper, then it just okay, forwards directly. I think this is fine. What else is going to be broken here? I think this is fine thanks to this with location instance. So now all of this should be good. The lenses are going to be broken. Okay, maybe for this file I should do. For this file, I'm going to do that. And I'll come back to this whenever I'm touching a file that has slightly less code on it. And there I can zoom it back a tiny bit. Or maybe not, that's a bit too big. Okay, so here, plated is a thing I've used on expression, which is a lens kind of thing for things that contain like other things of the same type. Expressions contain expressions, so it makes sense to ask to a given expression, give me your sub-expressions, or transform expressions recursively, or merge expressions a given way, and plated is basically the boilerplate class for this. So here I'm gonna have to remove this parameter that no longer exists, which means all of those lift A3 are now lift A2, except the ones that are no 1. I should be careful. All of those 3s are 2s. That's 2, that's 1, that's 2, that's 2, that's 1, that's 2, that's 2. There we go. And all of those pure X that were just whatever was associated with a thing no longer make sense. Go away. There we go. Now, however, this is going to be wrong for some of them because for a lot of them, I no longer have directly the value that I need. I think for a lot of them, it's just going to be enough to use within f. Yeah, I think basically every time I do f on a sub-expression, I just have to use within. I think that's going to be right, if not all the time, most of the time. So I think just doing this and replacing by within f should be fine. So that should be most of the big errors in the AST now that we have changed the way the trees that grow thing works, should be fixed. Now the big thing is going to be fixing, and I'm going to go back for this because I don't need as much screen space, the parser. Except not parsing, but parsing parser. Why? There we go. Because all of those are like the rules. Oh, this is not actually. I'm gonna go back here. This is all the grammar rules to parse our language after the lexing has occurred. However, all of those are outputting the location as part of the type. For instance, here, type alias declaration contains the location there, which is no longer correct. So, how do I fix this? If I look at the declaration, so here when we parse this, I guess the simplest thing to do, if I want to keep the structure of my parser the same, which I want because it works so far, so, don't think that I'm broke, I think what I have to do is something that returns a declaration passed now needs to return a with location declaration passed. And here, that's just doing a tuple $1 and this instead of putting the location within the constructor. So that should be enough. I'm just gonna do quickly. So whenever we have something that is either declaration or statement or expression, and I think those need to be, there we go, followed by past, followed by closing thing. I think on all of those, we're going to replace that with location. Fascinating that it does some weird syntax highlighting. The syntax highlighting on this thing has been extremely cursed. It's great. Yeah, this seems to be working. I'm just gonna mass replace. And now I'm gonna have to fix a bunch of things. So the declarations here, I fixed this one. Now same thing here. This is now a tuple that contains the location. The location is no longer stored here, and I need to close the tuple. And this is not aligning properly. I should probably just remove the Bison syntax highlighting because it is completely wrong with any Haskell code in the file. Because I think Bison, yeah, I think that's the problem. Bison is the equivalent for C++, so I think it's trying to basically, like, it doesn't understand this syntax with Haskell types and Haskell values, and it gets extremely confused. So likewise here, this is $1. $1 goes away here. And I guess I could... Nah, it's fine to use parentheses. Okay, and here, that doesn't change. This changed, but it's again... I'm almost tempted to see if I can make a regex for this. Because this is going to be, I have some opening thing, then a bunch of non-space characters, and then I have $1, and then I have a bunch of non-closing curly brackets characters, and at the end I have space closing bracket. Okay, and I want to replace that with open the curly bracket, open parenthesis, $1, comma, the first group, followed by the second group unmodified, followed by a closing parenthesis. And a closing brace. I see a closing brace at the wrong place in the... Yeah, something is wrong. Okay, let's just redo this. What was wrong there? Oh, that's because it's in the second group. That's my mistake. There we go. Okay, that should be fine. So here, yes, that's one we want to replace, and we're going to replace that with $1. Yeah, that looks good. It's going to be replaced with a lot of spacing, which is a bit unfortunate. We can fix that later. Okay. So here, that's the only one that has some weird spacing. There we go. So now, hopefully, that should be most of the cases fixed. We could probably, at this point, try compiling and see what breaks. And I think the answer is going to be a lot of things. So many. Okay. Renaming. I thought I had killed that file. There you go. I hope I didn't delete the wrong file layer. We'll see. Something doesn't compile. Wrapped inner, okay. Oh, wrapped is a thing that already exists within lens. I mean, you know, I'm used to just piping shell commands directly into my editor and stuff, and this is just, you know, it's fun. Also, welcome. I don't think I've seen you on the stream before. So yeah, wrapped already exists within lens, so I need to find another name for this. Do I just name it inner? That's not the worst, because value is too generic. Yeah, I think inner might be better. Okay, let's do that. I'm just gonna align vertically because I had been asked this question a while ago, and I will not align things vertically in a project with more than one contributor because it messes with diffs. But being the only contributor, I can vertically align things, and I will. So here, renamed, that is no longer the name of the phase, is now called resolved. And name is not defined. I'm going to need to import name. Conflicting. Because here I've also kept past, which is incorrect. This is resolved. Just check if this is urgent. This is not. Expected kind, but path info. Oh, yes, that's a good point. That's something I broke last time but didn't fix. So one thing I've changed last time is some of the types have become specific to a given phase, because now the path info thing, which is like the path to a given name, is something that only makes sense when we're done parsing, where we just have like, A, we're looking at A colon B, which is some random thing. After we're done resolving, we'll be pointing to the exact thing, which is going to be module name identifier or something like this. So this type is no longer specific, like is no longer a generic AST type. It is specific to the past phase, which I think I might isolate to a separate group just so I can have a better vision of this. Past phase. And I think module is, for now, going to move here. Because I think module is no longer makes sense when we're done resolving things. So I can keep this. And just for the sake of not having to change the code, I'm just going to keep this with past explicitly. And as a result, I can probably do a deriving show here because the types are all known. There is no longer a generic type here, okay? And which other types are specific to this phase now? Path info here is specific to this phase. Okay. Which means we have a few things that we're going to have to change. For instance, pretty printing a module, there's no longer a type parameter to module, which I think is fine. That's just going to be the same thing. And I think we have the thing we had just seen, which is that some of the types, like path info here, still expect a type parameter, but it is no longer relevant. So let's move this back here with the module and remove the parameter. Okay. Type expression no longer exists. That's because I have removed it in favor of that's just a path info. Which also makes it very clear that this is a recursive structure, which is the thing that I got wrong when I was writing the test and writing the arbitrary generation of values. I didn't realize this was self-recursive, and therefore this was just growing absolutely and using all of my memory. Okay, those go with module. I don't know why I didn't bring them here. A module is a semigroup. And this hasn't changed. And it is a monoid. Okay. So the printing printer only works on... That's fine. That's fine, I think. Actually, there's no reason it should only work on something like this. It doesn't make sense to just pretty print a thing on its own with those options, but I guess I could still just, for when I have other forms of the AST I want to print with a different top level type, I think this is perfectly fine. Okay. And now this is what I was dreading. This is no longer correct. So basically what this is saying is like, I'm saying make a show instance for that type. And what it is saying is like, well, within this, there's going to be some wrapped expressions for the given phase. There's going to be some wrapped statement for the given phase, or maybe not, actually depends on what the type family is. Since what type that actually is depends on what P is, and it could be, you know, anything. I mean, it can't because it's specifically an AST phase, but, you know, in principle, it could. We can't just make it a arbitrary show instance. We need the guarantee that this show instance only exists. Everything within the type has a show instance. So here I was using the big class here with all of the type families as a way to bundle all of the constraints. But now I have additional constraints here. So I think I'm just instead, and this is where I think I'm going to need undecidable instances, because I am bringing type families into the mix. Instead, I'm going to introduce AST constraints, which is going to be for a given phase P, what are the constraints I need on the types of the type family. Oh, I am a bit late, but I haven't communicated on it on social media because, again, the last few weeks have been a bit difficult. I've created a second YouTube channel in which I've started uploading all of the backlog of the streams. I'm missing 2 of them. I'm missing the very first one because I didn't get it in time. Twitch deletes them extremely quickly. And it's not a big deal because it's the one in which I had hardware issues and I didn't make any progress. But I'm also missing, and I'm sad about this, I'm missing the stream on the 1st of April where I found the bug in Alex that had been there for 7 years or something. So that was fun. But otherwise, I have all the streams. Some of them are already uploaded. Not all of them are uploaded yet. They are uploaded raw with no comment, with none of the chats, no subtitles. It's just like an archive of the streams. But I'll finish uploading them, the other ones, today, and I'll communicate on social media about it. And give me 1 second. I need to do a tiny bit of moderation. I have to type a message to explain. Yep. Sorry about that. Like, I'm not a big Twitch streamer. I have, like, 200 subscribers or something, followers, not even subscribers, and I get a spam bot thing like this every single stream. I don't know how bad it must be for like large audiences. Anyway, so here I'm gonna list all of the things, all the constraints I expect on all of those types, associated types, and other kind of things within like the different phases of the AST. And for now, the only thing I need is basically the show instance, which is only used for debugging purposes, but that's still something I'm gonna need. So that means I'm gonna need show. Yeah, I don't ascribe to this view of bots as people, not yet at least. Not until we have AGI, and we're gonna have AGI anytime soon. Okay, yes, show of an annotated declaration for the given phase, show of the annotated version of the statement for the given phase, show of an annotated expression for the given phase, and show of the one associated type we have now, which is the name type at the given phase. And now this is basically my list of constraints. And in every single instance here where I have this like qualifier for the instance, I can just replace this with AST constraint, I think I named it. However, I think this is not going to compile just because, let me check actually, maybe it will. No instance for show, declaration passed. Rising for the second field, interesting. Okay, so here I still need interesting, it doesn't know. Oh wait, it's just a declaration doesn't have. What does that mean? Because here the type is known. It's able to resolve the type family, and it should know that therefore this is a tuple of location and declaration. Therefore, it should be able to have a look at the show instance of declaration. But maybe the show instance of declaration is wrong. Oh, maybe it's because I have this constraint. So maybe I need here, that's a bit annoying. Maybe it's gonna be enough to just say that? Legal use of type family annotated. Perhaps you intended to use undecidable instances. There we go. That's what I was expecting. So, what that means. When GHC does instance resolution, it has a lot of checks in place to make sure that this always terminates and never ends up in an infinite loop of trying to resolve. And one of the constraints is whenever we do substitution, the substitution should substitute into something that is smaller. Which smaller, I'm not sure exactly how that's defined, but basically, when we replace aliases and things within the constraint, we should always converge towards something finite, which, as soon as we have type families, becomes impossible to guarantee, because I could absolutely have a family A that associates to int the family B of int, and B associates back A, and I have an infinite loop of family associations, and suddenly trying to resolve constraints would be an infinite loop, and the compiler would just like never terminate. So the compiler does not allow this kind of constraints in an instance, except, you know, if you really need to. If you really need to, you can use the undecidable instances, which basically removes that check. It is a trust me bro for the compiler of like, I know what I'm doing. I know this is going to terminate. It's fine. You don't have to check that it's always smaller. So I think I never want to enable this at the project level, but I think here, I think it's fine to enable for that file. And that should... And this, if GHC goes into an infinite loop, I'll have a demonstration of what not to do, I guess. Okay. Oh, interesting. There's already an instance. Aha. This might be a good reason to not use tuple, is I might want at some point to do interesting things like this. Here with location, the problem is I've defined it as just being a tuple, but there is already a pretty instance for tuples that will print the full tuple, which is what I want for most cases. So in the case of with location, if I want to skip the value, I have two options. Either I remove this instance, and everywhere I have pretty for something that is within something, I have to do a map pretty within, basically. Or I have to make with location a new type. I think that's better, so I'm just going to do that. So that's a new type with location. No, actually, no. Yeah, it's just going to be a wrapper around a tuple. That's just the easiest. There we go. And I'm going to need some kind of lens for this, which I think is just the same lens, but I need to... Do I need to have a prism for this? Or can I just define... Let me think for a second. Actually, this is going to need show, which is fine. Because I'm going to need basically to have, for my instance declarations that we defined earlier, I need to have a way to like, okay, how do I modify the thing within? Which is no longer just the second tuple accessor that I was using before. I need a dedicated lens. And I think the biggest difficulty here is how do I name it? How do I name this lens? Because I've already used the generic name within for the class. The locatee, because it's the value that's located. That's horrible. Let's not do that. Unlock to remove the location. That's not great. For lack of a better idea and to move forward, I'm going to use unlock, but I don't like it. Location, yeah. Located, I think, is better than locatee for sure. Yeah, located, I'm okay with that. Let's do that. The located was going to be a lens from a with location A to an A. I don't know if I need the lens to the location itself, but it doesn't hurt to have it. So that's going to be a lens of with location A to location. So that's basically, I'm going to write it manually, and then I'll see if I can simplify. Given some function f and a with location that contains the location and the value a, this applies f to the location, and then this remaps back that gives me the new with location. I can rewrite this a better way. This becomes lift a2 of with location, f of the location, pure a. There we go. Can I do something better than this? Could I compose this with underscore 2? I guess. Yeah, basically lens prime is the yeah, I guess I could use coerced. And I think you're right. In the case of the located thing, I don't have to necessarily have it be. That being said, I think I want to force it to be like to have the same type in output, because I want to use it in the AST where it's gonna be used that way, I think. And I think in the worst case, if I ever need, I can just coerce the underscore 2 or something. So I think I'm gonna keep it at A, even though it could be indeed a full lens that changes to a with location B and changes the inner type. That being said, it will cast properly. Yeah, it will cast properly. I can just do this. You're right. And located, yeah, it is a course of underscore 2, I think. But I don't like using course if I can avoid it, and I think it's always good to like try, especially for lenses, to get a feel for them. Writing it down is not the worst idea. This is also just gonna be a lift A2, but this time the location. Actually, I don't even need to do this time a lift A2. I can do a with location of f of a. I guess I could do the same thing here by doing a flip, but that feels inelegant, right? No, I think I'm just gonna keep it that way. Okay, so now that means I can go back here. I can change my annotation class to here. Instead of being underscore 2, this is located. And here, the pretty instance for with location is now pretty of view located. Okay. Oh, the parser is wrong now. So let's go back to the parser. And everywhere I have. Oh, God. Everywhere I have an expression that is this followed by open a tuple $1, comma, a bunch of things, close parentheses, close the thing. I will replace this with location. Actually, the tuple is the same. I could. So I have a group which is parenthesis $1 a bunch of stuff, closing parenthesis, end of the group, close of the bracket. There we go. Every time I have this expression, I replace it by the same thing, but with location added at the front. That looks good. Oh, something is wrong. My parentheses are wrong. That being said, the syntax highlighting has been wrong the whole time on this, so... No, it is wrong in a few places. So let's undo this, and let's have a look manually. Oh yes, here I have the closing parenthesis that's not needed. There we go. Okay, so now that should be good, and we should be able to move on from the AST while this compiles. What's wrong with location here? Oh yeah, of course, it's not a function of 2 arguments, so all of this is completely wrong. Okay, so... let's do the thing I wanted to do in the first place. I apply the function to the location. That gives me the updated location, and within the resulting functor... Oh, thank you so much. There's absolutely no need for this, but I really appreciate it. I still haven't done any like rewards for subscribers or anything because I didn't think anyone would. But I need to figure out something. Thank you again. I could do something like have all subscribers listed as contributors in the project or something like this. I need to think about it. I just didn't think this would happen, so I didn't have a plan. So here within this is getting name test cases after name releases after subscribers. Numbers for releases are a thing of the past. Do I want here to replace? Because this is getting complicated. I mean, it's not monstrous, but one new esoteric language per subscriber. I don't like using course, but this is definitely the simplest version. And course is defined in incredible data course. Yeah. Note that this is not an unsafe course, and here the compiler will check that this is fine. And here, since this is a new type, this is absolutely incredible. What was this esoteric language like? Because that's an incredible name for it. Like, it has to be pun-based, because I think in every single language, hair salons have, like, bad puns in their names. Fantastic. Absolutely fantastic. Okay. Couldn't match the representation of... Interesting. Is it because... Or is it just like I need to course dot? Nope. Okay, how would that work? Because underscore 2 and underscore 1 are functions that have the right shape. But do I need to coerce the argument? Do I need to coerce the argument and coerce the result? That's why I don't like using coerce. This is a bit of the magic button. Yeah. I think I'm just going to write them manually. That's a bit more verbose, but at least I know what's happening. Coerce is fine. It's not unsafe coerce. It's like the compiler guarantees that it's representationally equivalent, therefore it can do the conversion. And here, since I'm using a new type, at compilation time with location A is replaced by just a tuple, so they are equivalent, and the coerce is basically a no-op. Coerce is just basically asking the compiler, check that those types are equivalent and do the magic, basically, like allow this. But here I'm struggling with figuring out exactly how the lens works, the lens to have the coercion. So I think I'm just gonna write it manually, which means again location takes the function to apply within the thing, a with location that has the location and the a value. And what we do with it is we apply f on the location. That gives us the new location value within the functor. Why am I using a new type around the tuple rather than a record type? That's a good question. Why am I using a new type around the tuple rather than a record type? That's a very good question. I think out of habit, but that's not a good reason. Yeah, I think you're right. I think this next 7 question, maybe all of those problems are solved by not doing this, and instead naming the fields, which is almost always better than using a tuple anyway. Yeah, you're absolutely right. Thank you for that. That means I'm going to have to do some more regex on the parser file. That's fine. Therefore, with location is a record that contains. And here, I guess, since I was ready to use those names and have those names be top level declarations, I can actually just do that with location. That's a location. And located, which is our a value. And now I can just generate the lens, and all of this goes away. Okay. Yeah, I think you're absolutely right. That's the better option. Does that change anything in the AST? I think it only changes the pretty printer here. And yeah, because this is still the same. This is view located. That's the same. That hasn't changed. What changes, however, is going to be the parser. We get back to this. But this time it's going to be a smaller change, because whenever I have with location open parenthesis $1 comma something, this is now going to be with location $1 and the thing, because it takes 2 arguments with the location being first. Okay, let's go back to that. Oh, and I need, no, location is still correct for the instance. I think I saw a no instance of show. That's always good news. No instance of show. Oh, because yes, of course, location here. This needs deriving. Do I need the others? I think show is fine. No instance for pretty name type. Ooh. So what that means here is that I need to guarantee that at all times, do I put that in my type constraints or do I just put it here manually? Let's see, does it give me an issue? No, it doesn't give me an issue directly. I think it's fine to just put it directly there then. So this requires that name type of p has a pretty instance. But no, that should be fine. That should be fine. Just gonna have to do that in a few places. Yeah. Okay, yeah, because it's gonna cascade. Okay, so I'm gonna go back and in my AST constraints here, I'm gonna add the same thing. Since this is the constraint type that contains all of the constraints I'm gonna need, so I don't have to repeat myself everywhere, I'm gonna do this. And this. And now I can just replace all of those by not all of those actually, but that's fine. I'm going to do it manually. Constraints. There we go. Module not required, path info not required, input not required. Yes, there we go. Lift A1, that doesn't exist indeed. That's just lift A. Or actually just, you know, fmap. But we're at the point of compiling the end of the file, so they're starting to look. Aha. I'm just gonna move here so we can see what's happening. What's the error? We have an error on line 499, which is this one. So I think this within is not correct. So within is a lens that given... but maybe plated is slightly different. Let me have a look at the definition of plated again. Because maybe it's not a regular lens and therefore I can't just do that. Oh, that's not the version of this file I want. No, it is a traversal. Okay. So it means it gets a function and I need to apply the function to the expression or to the thing. So that should be fine because within being a lens, this should transform or is it actually within .f of E? No, I don't think that's correct. No, I think that's absolutely wrong. What am I saying? But no, okay. I think the problem here is I'm applying the lens. Should I do? within takes the function and returns a function that given the value no, that should be fine. So I don't think this is, I think within FE is correct. I just need to convince the compiler of this. The question is how? What's the error? Oh wait, I didn't save, so I get the error for the wrong thing. There we go. In the second of argument of lift A2, which is within FE, this should be an f of an annotated expression P. So whatever the functor in which f puts the thing, this should be that. And instead it doesn't know. It's like those are ambiguous. Is my definition of within resulting in something that's ambiguous? Let's see. Oh, is it because it's not, it doesn't figure out that's in an injective type family where it's always going to be. That might be the issue, I think. It doesn't know that there's only one possible value applied to, and therefore within is always going to be of, aha. How do I fix this? How do I convince the compiler that this is always going to be correct here? There are a few ways to indicate. I know there's like, how's it called again? It's the outdated version. Let me actually quickly have a look. The question is, can I use the injectivity notation for a class like this? I think it can. And is it a tuple or? Yeah, okay, it's the, okay. So that means here that this, I should be able to say that annotated inner phase depends explicitly on inner and phase, as meaning there's going to be always only one combination of only one. Is that true? That's not actually true. That's not actually true. I could have two faces that output the same thing. Huh. So maybe my use of within is incorrect. That is not the correct approach there. Would it help if I were to qualify explicitly what within I'm calling, because then it becomes Or wait, is it just that I need to say here? Is it just that I need the constraints here as well? Well, that's more that I need. Is it just that I need to say those instances are in scope, they exist? Oh, annotation. Not annotated. Annotated. Annotation. So we do still have the same issue. That's not the problem here. Actually, this constraint actually is probably overkill. I think what I meant to say was there is an annotation of expression for this given phase. I think that's enough for what I wanted to do, but that doesn't fix it. Should I then give up on the approach of the class and go back to a regular type family then? But I kind of need this within lens. That's something I want to have. I want to be able to write generic code that works regardless of the I guess if I have the requirement that it's always a functor, then suddenly this becomes traverse or fmap, and it just becomes a lot easier. But I don't want that because I want to be able to say no, the associated type is an unwrapped type because that's extremely useful. Let me think for a second. Worst case, if I can't figure this out, I'll comment the instance of plated that for now I don't use to move forward for this evening, and I'll check exactly how to fix this in between streams if I can't figure it out. Okay, for now, let's see. I guess I could just explicitly annotate the within. Maybe that's gonna be enough. What else do we want to try? What else do we have in mind that would make sense here? I guess I could make. Nah, that's ugly. So, what happens if I try to explicitly state this within? That is giving me trouble now. Actually, do I just. One sec. Ah, too much. Not enough. Just interesting. Hmm. How is that not enough? What's wrong? Oh, yeah, of course. I'm an idiot. Sorry, sometimes the brain doesn't brain. There we go. That's what I wanted. Now, what happens if I try to explicitly say, okay, this inner is expression and the phase is P. If I explicitly qualify the within. Oh, of course, this is. Yes. Well, actually, within which order are the arguments? It's a lens, but the lens appears. Inners are gonna appear first, so I think this is correct. Let's try. If I do this, and I am saying this within is for an expression at the given phase. There we go. Second argument. What are you saying? Oh yeah, of course, because I'm not giving the arguments to I'm not giving the arguments to the class. I'm giving the arguments within, and the type of within. Yeah, that's not gonna work. I guess I could try something else. Which is, I could here introduce go, which is going to be a lens from with location. Wait, no, from annotated, because I'm writing a generic one. Annotated expression for the given P here. I have scoped type variables. This P should be fine, should be the same. And to an expression, and go is within. That way I cast basically this. I explicitly labeled the within function, and here I can just replace within by go. Let's see, would that make the compiler happy? It's happy for this one, so that works. It's unhappy for this one because I'm traversing with F, and now it should be traversing with go F. Traversing with go F. That should be good now. Nope. Ha! Okay, so Go has the correct type, so it's happy, and now within is not correct. Let me check, because does this match? For the correct inner zero phase zero, does this have the right shape? Yes, because inner zero phase zero will be an expression of the given phase. Yes, annotated. So we've just moved the problem further down, basically. Let me think here. I think the problem is just since within is taking only as argument values of values that are the associated type families and not the types on which the class is defined, the compiler is saying, I have no way to know which of the definitions of within I should be calling. I think that's the problem. So if that's the problem, there are two solutions to this. Either I give proxy values of my given argument types, so expression and p in this case, to make the compiler figure out what type that is, or I need to find a way to tell it which of the within that is with type applications. And I thought that would work with I thought this would work with right, it requires inner zero and phase zero, which are expression and p, but the problem is I think type applications require actual types, not type constructors or arbitrary data cans like I'm doing here. Yep. Hmm. Can I do type applications of non... Let me see. Class methods type arguments include the class type variables followed by any variables. The problem here is that this is what I have, but type arguments require actual types, which I don't since I'm using data kinds and other fun things. So I think here that means within needs a proxy. That's interesting. I'm surprised because yeah, I'm surprised I can't do type applications with non, as I say, non-types. I'm surprised I can't do type application with things that are correct that just happen to not be types. That's surprising to me. Let me actually check that this is actually the error. So if I have, it's fine that it doesn't compile. It just means I have all the packages and everything in scope. If I have a function f that is undefined, that's fine. I don't need to actually call it beyond type checking, but its type is for all a of kind int. proxy A to int or something. I will need import data proxy. Okay, that works. The type of f is proxy of A for to int for any. Huh. So it would allow me to say f at string. To a visible type argument. Why? Or is it because... Is it because proxy is defined as having... I'm getting into the weeds there. I think I'm gonna just give a proxy. No, it is polykinded. Okay. Huh. So why can't I do type applications for... That's annoying. So if I have f, which is a proxy of a an int to int, and f is defined as undefined, type of f, proxy of a, and I can't do... Oh, wait, is it just because I'm using GHCR wrong? Nope, that's not. Okay. Oh, wait, no, it is. Expected kind int, but string as kind. Okay, so... Okay, so that's good. That means I can do type applications of things that are not... I can do type applications of things that are not types. So if I try again, but instead of defining f as being proxy int, can I use something like maybe? Something that is therefore type to type. Except I need import data kind. Can I do this? Yeah, I can do that. So it is possible to do a type application with something which is not a type, but as long as the kind is correct. Do I get the same error if I do something with the wrong one? No, I get a kind error, which is what I expect. So why here? Because within is expecting a type. That's fascinating. Let me see if I try to... If I comment this out. Okay, I have some errors in the parser, that's fine. I should be able to say... No, I don't have... Does it compile enough that I can try to see representation AST? Aha. Aha. The for all has the K first, which is the kind of the polycandid inner. So here, I think the within needs to be first. This is a type to type, which means I'm gonna need. Oh, the kind is already imported. Perfect. Okay, inner phase. Aha, of course I've said type. That's not correct. This is AST phase type. That is, however, extremely annoying if I have to specify this every time I want to use within. Maybe that means I need to find another way to do this, because having to explicitly say what the type of within is every time I want to use it, if it even works, couldn't match. Yes. This is indeed inner expression P, because that's the inner value. Wait, no, it's not. No, that is was expression. Okay. Yeah, I think this approach is not gonna work very well, because if within is such a nightmare every time, I'm gonna do something else instead. Annotated is a type family within a class. And the only reason I haven't made it as a pure type family is because I wanted to be able to define within, so that I would have a generic way of accessing the thing within, regardless of what it is. But maybe that was a mistake. Because I don't have the guarantee that they're all necessarily a functor, because here in this case, they're just the inner value. So do I need to say here? So I think this approach will not work, because this is just absolutely a nightmare. So this might be something like this, inner expression P, and therefore the third argument is going to be wrong as well. No, it is expecting expression. Okay. Wait, unless this is because I am using. Is it because I'm using within wrong? Because this expects something that to an expression. Wait, is it just because I have been using within wrong the whole time? That'd be nice. Because within, the type of within is a lens from annotated inner phase to inner. And what did I say here? No, that is correct. Oh, but perhaps, yes. There we go. We're almost there. Actual, so within. Is it gonna be actually this? I don't think that's correct. Nope. Ah, there we go. There we go. I don't have a way to guarantee that here the inner is the same, and I want to guarantee that. There is a solution here. There's a solution here, I think, and I think it's to remove the polykinded thing. The reason I have done this is because I wanted to say that maybe we annotate things that are not parameterized by the AST phase, and therefore I give anything here. It could be an int, could be something annotated by the phase or not, but maybe instead, rather than doing a pure polykind, I say that this is something that to an AST phase associates a type. And there is no longer an inner type because the inner type is always inner phase. And I think this, by removing the polykindedness of this, will be a lot simpler. And now that means go here is a lens to this. That is correct. It doesn't need the kind here because we're not in the case where this is polykinded anymore. Couldn't deduce annotation expression P, which is the constraint that we need. So I just need to say that there is an annotation for this expression at this phase, and that should be fine. I think, yeah, I think it's trying to make it generic of the, there we go. That was it. Trying to make it generic over the kind of the thing we're annotating was the problem where like it was getting confused. It might still be possible to express, but it might get into the like a bit into the weeds into how to express it. Was it just a problem that I just needed this? I don't know, but I think at this point I can probably replace. Oops. Go back. Typing is hard. Go with within. And I think this is now working exactly the way I wanted. Yeah, okay. So that was the problem, and I'm gonna quickly, when I have an arrow, a new line, 1, 2, 3, 4, 5, 6. I will replace that by an arrow and a space. There we go. So now I don't need a 3. Orphan class instance. Yeah, that's true. I think I don't like this instance. I think I want to go the long route, and I think I want to actually explicitly say every time to ignore the with location or whatever, to ignore the annotation, because it's wrong to say that for every single time, like for the type with location itself, the way to pretty print it is to ignore the location. That's the problem of using a type class is I'm making an arbitrary. So I think I don't like doing this. I think I'm gonna not do that. And that means there's a few places where I'm gonna have to instead here, instead of pretty, I'm gonna have to do, I know this is, I'm gonna have to call the within. So it's gonna be view within. And that's gonna be every time I have, I can just let the compiler tell me what it is. No instance for pretty with location, yes. What? Oh, because I've put the pretty here. Yes, so those are no longer required. Okay. Couldn't match annotated. Um. Oh, is it because I'm using the wrong... Within is a lens, so view of the lens should give me the thing. Let me check. A module has mod declarations is a list of annotated declaration passed. So within is gonna give me... I guess for those, since I know it's a location, I can just do location and not try to do within. Well, I mean, that's for the module. The others I'm still gonna need to make within work. But that can be expressed with... Okay, so the const expression here. So I need to do a view within the const expression, which means I need a constraint. Yeah, there we go. And I am back to having the issue. I think it's just view is the wrong one. Control lens, because it's expecting a monad reader, which is wrong. So I am probably looking at... I'm probably using the wrong version. What is the... What is the lens I want? The lens I want is... It's this one. This is the same operation as view if the argument's flipped. That's not true. View is the one that requires a monad reader. Use is the one that requires a monad state. So I guess I have to use the operator version. Okay. I wonder if this has changed at some point, because this is the same operation as view with the arguments flipped is not correct. So this is just within. Expecting get... Did I use it wrong? It is the thing on the left. Const exp, yes. And I'm applying the lens within. I'm really reconsidering this approach to the class. If within is such a pain to use every single time, that's just not worth it. It is, however, possible I'm using it wrong. Yeah. Annotated is a non-injective type family. The type variables inner phase 0 are ambiguous. So here, maybe I will need to say that this is for an expression of P. With the correct spelling. Ah, just expression. If it's just that, if this is enough, yeah, okay, that's enough. That's not the end of the world. I'm still surprised. I was convinced that view was not the reader one, so I wonder if that has changed at some point in lens. I would be surprised. That's probably a break. That would be a breaking change. I'm not sure why the documentation says that it's the same with the arguments reversed. That's just not true. Anyway, that means here. Yeah, I'm surprised. So I don't know why the documentation says like this operator is view if the arguments flipped. That's simply not true. And I thought there was a function version of this operator. Maybe I was wrong and it never existed, but I remember reading this line of the documentation and being like, "Oh, view is there for this as a function," and I was probably wrong. Okay, so that means every time a pretty block, let's see, pretty block is I think I only use this for statement. So here I will rewrite pretty block to be for annotated statement of P with a constraint of annotation statement. P and here map pretty, and it's not going to be pretty, if I may say so. It's going to be pretty of within. And of course, I need to say that within is statement at this phase. Okay, pretty block here for the body. Will need P to be given as an argument. Full map pretty of would be a lot simpler if I kept the pretty instance of with location, but I don't like doing that. It feels wrong. Sometimes doing the correct thing is a bit ugly. So here I'm calling within on an expression. I guess if instead of having this annotation thing that's generic, I had three type families: annotation expression, annotated statement, annotated declaration, I wouldn't have to give as a type argument what the type of the inner thing is. And therefore, I would have three different functions, three different withins, one for each. But at least I wouldn't have the problem of having the same. Maybe that's the way forward. Maybe that's a way to reduce verbosity without, while keeping the option of having a proper type family for this. Maybe that's the right approach. For now, I'm gonna finish this because I have a path forward, and there's always gonna be time for cleanups later. Now, I need to do pretty of what is within this expression. This pretty block is gonna require a knowing what the phase is. Within here requires expression and the phase. Pretty block requires knowing the phase. There we go. I wonder actually if it would be fine. Would it work with just a partial type? In which case, I might be able to. I don't think I have partial type signatures enabled. Yeah, no, okay, it doesn't work anyway. Okay. This is an expression, therefore this is a pretty of within an expression at this given phase. I wonder if actually, no. Could I redefine? No, I cannot. I was thinking of them redefining another function that wraps within another one that changes the name of the type arguments, so I could make it explicit based on the first type of the first argument and avoid having all of those type applications. Maybe, but again, this works. I'm gonna do the ugly thing of making it work for now. I'll look into how to make it a tiny bit better at a later stage. Pretty block requires knowing the phase. All of this because I don't want to just to say functor. That's an expression, so pretty requires doing the within and I'm not even at the expression yet. Okay, here expression is where it's going to be a monster. Path expression, that's not an expression, that's fine. I can just delegate to pretty, that's fine. It's the ones that are called E that I'm going to have to worry about. So this is going to be E within. And here I might do the same thing where I declare, well, same thing, the thing I was doing earlier, where go is within expression and P, so that I can just, every time I use pretty here, just use go instead, rather than having to give a type application every single place. How's that? Wait, no, it is. That's what it is. Okay, so here, this is not something that requires name type, so that's just a pretty directly. There's no need for go. Annotated, so that's go as well. And we haven't even tried to compile the parser yet. So that's a struct expression, and I think, yes, that needs to be value will need to be a go. Can I use show? Huh, interesting. I am using... Wait, why am I using... Why am I using a show here? What here is requiring a show? Is this because I'm doing a declaration here which requires... Am I doing show at any point in this? I am. So I think here... I need to do AST constraints of P instead. And there we go. Now we have a bunch of errors in Alexa. Interesting. Oh, because this binding location... So I have something in Alexa called location that is conflicting with what is location. Oh, I have a bunch of things called location. I think location is a perfectly fine name for... I could just hide it. Hiding location. Rather than rename the whole thing. Okay. And now we're getting errors in the parser. Yes, I have a few places where I mentioned a type expression, and that's a type that no longer exists. That's an error that should not be too complicated to fix. There are no longer type expression passed. That's no longer a thing that exists. Instead, we just have a path info. There is no longer a module passed, it is just a module. And there is no longer, no, actually, there is still, but the name is still path info, so that should be all. Path info passed, so I still have a place. I still have a place where I do path info parsed. That's incorrect. There we go. And now, hopefully this compiles. And if it does, it doesn't. We're gonna be running the test to check couldn't match expression passed with location expression passed. So there's a place where I've written an expression and I should be returning a with location, and that's a place where I'm using second as a way to return something. This is probably here. Actually, just gonna do a quick thing with location. And no space here. I'm gonna, oops. Okay. So here I have, so array element is a with location expression passed, and I'm doing second of the one. That feels wrong. Because expression gives me oh, here expression gives me a tuple. Why am I doing this? Why am I returning a tuple when I... use expression. Where is expression used? Is it because I was discarding? I think it's because I was the way the parser was constructed. There were places where I didn't need expression was always giving me a tuple because I needed to be able to construct the expression with it or not. And I think this is going to get simpler now, which is good, but that means I have more things to change. Because I think this one was already like this before, and I need to change this. So this is just a with location of expression passed, I think now. Because yeah, here I was decomposing the thing to be able to construct the thing with the location as the first argument. That was a nightmare. I think this is just $1 now. Ah, no, there we go. This gives me location path info. So that means that is a with location first $1 and path expression of second $1. There we go. Because not all calls to path expression construct a expression as a result, I think. Because path expression is also used in a bunch of other places. Yeah, okay. Okay. So all of the use of second are not going to work anymore. So I think I should just be able to replace, here I'm calling expression. The resulting thing is a with location of the expression. I think most use of second here to unfold an expression, I can just remove. So this is getting simpler, which is good. Here the if statement does the same thing. It returns the location as but why does it do this? I don't think it needs to do this. Let's have a look at the AST for what an if statement is. That's just something, okay, so it constructs an if info. Oh yes, because the if info might be used for other thing than a statement, so I need to be able to return the location where it was. Okay, this is correct. So this is indeed not returning a with location, it is returning a tuple. That much is correct for the if statement specifically. And that means here that I am constructing a with location with the first of the $1 and with the second of $1. Is that just uncurry? That is just uncurry with location, right? No, because this isn't an if info directly. This is the if statement constructor. I guess it's an fmap if statement of uncurry of with location, but yes, that's the constructor. There we go. Okay, and I guess there must be another place. Else if. What's an else if? takes as an argument the if info. So here the if statement is indeed the second. Here it makes sense to remove it. I don't need the location at this place. Okay. And then else info here, I don't need the location. So this, yeah, this is wrong. So block gives me a list of statements that are passed. Oh, that's probably not correct. Those are probably some with location statement passed. Yeah. Which means this gives me that, which for the case of an else block is just that list. So that means that is an else block of $1. The problem of large replaces is I got a few things wrong. Okay. Next, which other use of second do I have? 4 is an expression. That's not correct. I can go back to doing this for expressions. 5 into 3 for 5 is an expression. That's no longer required. Yes, that's no longer required. Path expression. Path expression here. Okay, that one is correct, I think. Okay. In the first argument of while info, indeed, that's an expression, and I'm using second, which is not correct anymore. Do I have any other use of second I have missed? With location expression passed, that's just S1 again, $1 again. Likewise here, there's no need to do this expression. What am I doing here? This is something that returns a tuple location expression passed. Why do I do this? Where is index expression used? It's only used as an expression, therefore it is fine to return a with location expression here. Yeah, this is making a lot of things more consistent, but at the price of more changes. Here, the location is not required. And it is not... So this is an index expression. No, I need to bundle the location. I need to bundle the location. That means I need to extract the location of the leftmost argument here. So this is a with location, with some location first, and then an index expression, which is just $1 and $3. As in this expression and this expression. Now, what I need here is I just need to get the location of the first one, which is this. Wait, I've been hiding location. No. I guess I can just use the non-lens version. Like this. Actually, instead of trying to compile, all of those functions below used for sub-expressions have the same problem. I'm gonna fix them because all of those have the same problem where here I'm gonna need to create a with location. The first argument is gonna be the location of the first sub-expression because it's left recursive. And the second argument is going to be the thing I construct. And here I don't have. There we go. I'll have to unpack the expressions. Field expression, where are you used? You're only used here. And in the case of a struct expression, this is a list of identifier and okay. That is indeed identifier expression passed, except it is not that, it is a with location. Expression passed. Therefore, it's this. Perfect. Literal expression, why are you giving me the location? This is used only in one place. That becomes a with location of a pass expression. And like all of those others, this becomes... Aha. So here, however, I'm going to need to keep this tuple thing because here... Yes, the first part of the tuple will be the location. Okay, so that's correct. So here for literals, where was the int? There we go. This one. So here, this returns a with location. The first argument of which is indeed the first element of the tuple of matching a literal. The second argument of which is an expression that does not contain the location anymore. Get int literal. Yep, that's fine. And I think all of those functions take a tuple. They do. Perfect. And now with location here, $1 is indeed the location, so that's fine. And I don't need to give it here. There we go. Operator expression, that is only used, to my knowledge, here. So it's back to being, well, it's back. It is also just a with location now, which delegates directly. Perfect. That means all of those are gonna be as well, all the way to compound assignment expression here. Those are all no longer location expression passed, but a with location of expression passed. Aha, and I have a helper here for a lot of them, which is gonna simplify a bunch of things. That is correct. I'm using the location of the operator. Perfect. reference expression $1, no, the location is not needed. Second, not needed. This is just the expression forwarded. Yes, all of those binary expression are giving the whole result of the expression, which is a with location expression, which is perfect. Here, however, I have okay, so binary expression is the helper I'm going to have to fix afterwards, but it's going to fix everything else. The last one I have to fix is this one, which returns a with location of the location of the first expression and a cast expression that is just $1, $3. No need to extract anything. There we go. And I think the last thing I have to fix, at long last, famous last words, is here, given a with location of a past expression, combine the two of them, and I just need a constructor, and the constructor is not taking the location anymore. It is taking the with location expression past. It is taking the same thing, so I could rewrite this whole thing as constructor expression 1, expression 2, and the result of this is a with location. That's not true. This returns an expression. I'm going to re-inline it. That's the constructor for the expression. And that's the actual location expression, sub-expression with the location. And I wrap this in something that contains the location. And that is being done by getting the location of the first one, which is exp1 in this case, and no longer in the context of a happy expression. And the second argument is cons exp1, exp2. Okay, let's see. Parse error. This is in a cast expression, okay? I see. Okay. I have somewhere something that says with location expression here. The function continue statement is applied to too few. Okay. What? No. Go away. So here I have a with location of a statement passed. Yeah, of course. The continue statement is a constructor for that statement, but it doesn't take the location as an argument. So this is with location $1 continue statement. This is going to be the same thing here, where this is going to be a with location $1 of the break statement. That's fixed here. And uncurry expression statement is completely wrong. This is, again, a with location of the location. I could make, I have the binary expression helper. I could make a unary expression helper for this. Nah, it's fine. It doesn't happen that often. But I was doing here. So that's the location of the thing. There we go. Okay, so I still have a few tuple errors, but now I no longer have grouped expression here. It's those. Grouped expression should be a with location of an expression. And that's just over 2. Perfect. Okay, so I have the same thing here. I didn't catch it because I was decomposing things manually. Okay. Okay, so this is... Oh, there's not a lot of them. That's good. So this is going to be a with expression, with location of the location of the first argument. And the second argument is going to be the expression that we return, which is the field access expression, which takes as first argument the expression itself. There we go. Call argument is the same, that hasn't changed. Perfect. Here I'm making the same mistake again. Oh, no, actually, this is correct because path expression is indeed a tuple. So I need to decompose it, but I don't have to decompose it that way. I can just use first, second like I was doing. So this is a with location, which for once, indeed, first of $1. And the second argument is the call expression with the second of $1 and fold of $3. Okay? Array expression, optional comma list array element. That looks all correct. With location. Okay. Are we done? Is this finally over? No, we're not done. The function array expression is not applied to... Okay. Yes, because here I'm still giving the location, which is wrong. Here, likewise for the index expression and the struct expression. Wait, no. Those are correct. This one was wrong. In the first argument of location, okay, so there's one for which when I call the path expression, I'm getting a tuple and I'm using location on it, which is wrong. Here. Here, this is not underscore location. this is first. Path expression. Nope, that's fine. Okay. Are we finally? Nope, not yet. Location path info with path info. So, what returns a path info? Struct field returns one such thing. No, it returns identifier. That's different. So path expression, and I think that's the only one. Yep, it is the only one. So wherever I have a path expression is where I probably do something wrong. Expected name type passed, actual location path info. Is it here? Nope, the code expression is correct. Is it here? Path expression, there we go. I think that's the one. Where here I have removed the second and that was wrong. Okay. Getting there. Is that the only error left? Looks like it is. So it is still a location path info. So I have a last path expression here. Is that the last one? It takes longer to compile, that's a good sign. Yep, that's good. We're out of the weeds. Now, module is not something that has a past type anymore. So now it's gonna error in the tests at this point, I think. Here I'm using second to extract the thing. That is not correct. This is located that I want. And now in the test, everywhere there is module past, I need to replace that with module. Likewise for path info. Hello, welcome. Oops, that's wrong. I'm replacing path info past by just path info. There we go. Okay, we are still making the tests compile, which is good news. Which is good news. Aha, yes, of course. Here I think I have a helper called arbitrary location or something. Oh, I never uncommented this actually. I should probably go back to that at some point. Yeah, of course I never, because that's when I found the bug in Alex. That's where my tests were not working and I couldn't figure why, and because it was a bug in Alex. That's what it was. Okay, so I have a thing called debug location here. I think I can just, I don't know where it's defined. Probably somewhere at the end of this file. There we go. I can probably just replace it by, I'm going to copy paste it here. I'm just going to say instead of all of this that there is an arbitrary instance for with location A as long as there is an arbitrary instance for A, and arbitrary is gonna be doing a with location of this debug location in the arbitrary value of A, and shrink is gonna be, I think I forgot to do that. With location is a functor over A. Is it an applicative? Yeah, I think it is. I don't think I want to make it a monad. I think that makes no sense, but I don't think it can. Does that make sense? Is that just... What would that be? No, it would need some constraint on like how to... Yeah, it's close to the writer monad, but without the monolith constraint on the location, that wouldn't make any sense. No, even applicative would make sense because what to do with location? Yeah, no, that's just a functor. So shrink is just going to be... Wait, what's the type of shrink again? I think I have to... It's given a value of that type. So given some with location L and some A, it's gonna be a map with location A, L of shrink of A. There we go. Okay, this compiles. The parser still compiles because I haven't changed anything significant. Hopefully now we should be at the point where the tests compile. If that's the case, close. Okay, I probably have a bunch of places that still give a debug location. Yes, that's exactly what it is. Debug location. All of those constructors do not take a location anymore. That was declaration. Let's go to statement. There we go. Oh, I saw it here again. Yeah. There we go. Probably should uncomment this and try doing the round trip tests with more expressions. But first, let's make it work with this. And here, remove the debug location. That is no longer required. Okay. Where are we now? What's missing? I have, yes, in statements and declaration, I did remove the debug location from arbitrary, but not from shrink. So now I need to go to statement. Here, there we go. And I have the exact same thing. Okay. And now, okay, those compiled. This is just a module. Is that it? Not only that is, but the tests are passing on the first try. Which, given that there isn't a lot of tests, doesn't mean much, but it's still nice. Let's actually try I had commented this out for a very simple reason, which is I was debugging the round trip test. So, what that test does is it generates an arbitrary AST, completely arbitrary one. It might be completely nonsensical, that doesn't matter. Pretty prints it, so prints a file that corresponds to the AST, passes it, pretty prints it back, so that formatting is not an issue, and checks that we get the same result. So checks that the pretty printing passing things are indeed consistent, and that there's no point where like we pass something and then it results in a different AST. But I was debugging this when I found the bug in Alex. So and also I had the problem of the expression just completely exploding and becoming absolutely too big. So I did at some point constrain the expression to just this subset that doesn't have any recursion because it's just a literal basically. So any expression was just a literal and nothing else. Can I uncomment this? And what happens if I try with this? Will I run into another complete explosion of... Or did I probably scale every arbitrary instance? This is probably going to be a lot slower, is the thing. Indeed. Okay, so let's check that I don't have... Wait, I probably need... Yes, okay, I know what's wrong. This scale does nothing when the arbitrary instance might still pick one of those, so I still need to do... I'm going to keep this. And when the size is 0, pick something that's not recursive. Otherwise, pick one of those. And now that should be at a somewhat reasonable size. Aha! And now we have something that's wrong. But that's probably not something wrong that we introduced this evening. That's probably something wrong that was already there that we didn't see because the tests were not trying things that were a bit interesting. Actually, I could leave 100 for now until we fix this. What do we have? So we get a pass error when we pass. That's interesting. We find, so what is this? We're generating a constant of name underscore and of type underscore, and it is a cast expression of 0 within parentheses as this within parentheses. That looks fine to me. So this should pass. Oops. So let's copy it. I think I did. Open a GHCI. Oh no, this won't work. I need to quit this GHCI. I've had this issue before. Since Alex and Happy depend on files that are generated at compile time, I need to relaunch GHCI, otherwise I will not have the up-to-date version. There we go. Okay, so if I pass an expression, and that expression is this, oh, because that's not an expression, that's a module. So let's parse module. Okay, so expecting identifier. I think this is just a problem with the pretty printer. because the parser for a cast expression expects a type expression, and those are not. Those do not contain parentheses. So that's a problem with the pretty printer. Where in the pretty instance for an expression, in the case of a cast expression, I am putting parentheses here. There we go. So if I actually reload this and try again. No, I would need to fix, I would need to. Yes, no, this would work because now the pretty printer would do this and it passes. Okay. Next, what do we get? I think that's the same thing. A reference here. If I look at this thing, this takes a path expression which doesn't have parentheses. That is the pretty printer being wrong again. That was in a reference expression. Which I think I could summarize as it's fine to use parentheses when I have a go, it's not fine to use parentheses when I have a pretty directly. So parents pretty here is probably going to be wrong as well. Because that's a struct expression. And a struct expression starts with a path expression on the left-hand side. So yes, the heuristic works. Anything that's still within a pretty should not be parenthesized, but anything that is within a go, okay, that should be fine. I could almost put the parents within the go, actually. Okay, what's next? Const nothing type nothing equals. This is a call expression. Ooh, this one is tricky. So that is a declaration of a constant. The name is underscore. The type is just underscore. And the expression is a call expression. That's the same thing again. That is the same thing again. I have parents on the pretty. There we go. Ooh. What do we get? Ooh, that's my golden test that's broken this time. So something has changed, but the round trip test passed. So if I look at my test, is that basic.golden? I do indeed have call expressions with a print here. It's fascinating. Okay, so I should probably just... Oh, and I have spaces here. That's very ugly. That means my golden test is kind of bad. I guess it's fine because this is basically we pass with pretty print and we check that we always have the same thing that we used to have before, which as long as the passing works should be consistent. And here I've changed the pretty printer to be correct, therefore the golden file is wrong. The simplest thing to do at this point is just to remove the golden file. And now the test is just going to regenerate it. And now we're good. Aha. What is this one? Oh, so that is interesting. This is a struct expression, I think. Yes, it is. And path info, path name. And it has no field within. And if I look at the parser, I am fairly convinced that it must be non-empty. Yep, this is a comma list field expression. It makes no sense for a structure to be non-empty. Let's look at the structure declaration. Can a structure have no fields within? Is that something we allow? And I think the answer is no. Actually, I could just look at the AST. Struct info. Nope, this is a non-empty list of identifier and type. We do not support empty structs. That makes no sense in our language for now. That means that, as a result, a struct expression cannot be a list of identifier and annotated expression, because that is incorrect. It needs to be a non-empty. Which is fine. That should not change much the test because the generation is going to be the same. Does this change anything? I think if anything, it changes something in the parser. How do we do for a struct declaration? I use non-empty from list. Okay. So now for struct expression, I am going to have to do the same thing where I use a non-empty from list. Is there anything else that's going to be broken since we've changed the AST this time? Yes. In the prettifier. Okay. How do I do for the prettifier of a struct info? I just open a do block and I do a to list. Okay. I guess I could just do a NE to list of my fields, and that's fine. Okay. Okay. And now tests are all passing. Perfect. But I'm going to try something now that this is looking good. I'm going to go back to arbitrary and I'm going to look at all of my scale function that are currently doing a div 100, and I'm going to change them to be a div 2 instead. And we'll see if the size of the generated AST is absolutely monstrous and this like makes my computer lag. That's fine. I'm due to my setup. So the question is like, does it hurt my neck to be looking down like this while I'm working? The reason I have a complicated setup, this I have an actual proper screen that I can look at without bending down like this. The problem is I'm programming on my laptop, which is not powerful enough to run OBS at the same. Well, it is, as long as it's not throttled by temperature. So what I'm doing actually is I'm outputting my laptop is plugged in my capture card, and I'm streaming from my desktop computer, but I'm programming on my laptop, which is why I'm actually looking down here when I'm looking at the code, and here when I'm looking at OBS and the chat. It's not perfect, but it works. But no, I'm extremely lucky. I have no back issues in my 30s. Cross fingers, knock on wood that it continues to the same moving forward. But I'll take that as a posture check. Okay, this still works with a lot bigger ASTs. Aha, I did get a fail this time. What do we have here? So this is a function named underscore. And here, what fails to pass is this. It's a function named underscore with no argument that does if underscore. Aha! I think the problem is that this is an empty statement, and I think that's not allowed, but it should be. Yep. Pass error, T delimiter braces close. I think that's the problem. So I think I have something here that's expecting. I have something here that's expecting a non-empty list and is getting an empty list, and that's actually fine. Let's see. If I go back to my AST, if I look at an if info, yeah, the body is a list. It's fine for if to not contain any statement. So an empty list should be fine. And I think in this case that's correct. I don't want to change that. Which means probably that my parser I have a block parser, right? It does a many statement, but many can be zero, right? Or is it some? I never remember. Many is from applicative, I think. No. Is it from control combinators or something? Okay. Time for my friend Google. Where is some from? It is from control applicative. Okay. Some is one or more, many zero or more. Wait, so that's fine. Oh, wait, that's not the many of, that's a custom one that I have defined here, I think. Yes, that's this one. And many supports the empty list. Huh. So there's some place somewhere that is expecting a non-empty list and is getting an... Wait, this is not the debug location. This is the real location. Therefore, that's line 4. 1, 2, 3. Huh. Do we have a real ambiguity in the parser here? Because an if expression, an if statement is if expression block optional else statement. We didn't parse an else, so the optional else statement is not there, so that's the end of this. And we were parsing a block, so that's the statement. I am not sure what's wrong here. Let's test the hypothesis that the problem is an empty block. If that hypothesis is correct, then a function with just an empty block should not pass. It passes. The fun body is an empty list. That's fine. Now, if I have non-empty list of statements, break, break, continue, return 42, that parses just fine. Perfect. If one of those statements is an if so here a statement after an if is line 31. So this is really a problem of if there. Something is broken after the if, no matter what happens. And if I have a break statement there, that doesn't parse. So something is wrong with the if. So if expression block, and we go back to block with many statement. I know what the problem is. That's an ambiguity in the grammar. I think it's parsing this underscore thing as a struct expression. And therefore, it's like that needs to be an identifier because it is parsing this thing as if it were a struct, I think. Yep. What does that mean? That means it's trying to pass the expression of the if, and it's encountering something that looks like a struct, and therefore it passes it eagerly. I think that's the only. If I go back. Ah, what's the way to do this again? There's a way to. There's no. There's not in my history. Really? Huh. I will want to get the debug information. No, the info, I think. Of stages passing pass of the Y. Okay. There is one shift reduce conflict. Only one. Where is it listed? Wait, I thought it was listed at the. Where is it? That's the grammar of all the rules. Terminals, non-terminals. Where is the. Huh. I thought it would list the shift reduce conflict. Okay. Conflict. Nope. Does it give me. Why doesn't it list me the conflicts? I thought it would. Is it the pretty option that I want? Nope, it's just printing the same thing. Where would I find the information about the shift reduce conflict? I thought it would be given here. I can just go to struct and find it. Well, wait. Happy find conflict. Where do I see the conflict? Why does it not give me the thing? Yeah, okay. Generating the info file is what I'm doing. The question is about how to find the conflict, and the answer is use parsec. Incredible. But it doesn't give me. Oh, state 6. I can't read. That's my fault. State 6 contains one shift reduce conflict. There we go. I encounter a So I am here when I'm trying to pass an expression and I'm passing a struct expression. I encounter an opening brace and I cannot differentiate between shift and enter stage 45 or reduce using rule 52. And I think by default it always uses a shift when it's a shift reduce conflict. And that is state 45, which I think the shift is create a struct. Yep. So I've encountered the path expression, a open brace and a dot. So 45 is the shift, it's the default. We are trying to construct a struct. And the other thing we do when we encounter 6 is reduce using rule 52. And rule 52 is that it is a path expression and whatever comes next is after. Okay, so this is ambiguous and our language is not able to distinguish between, at least using happy. Is there a way to solve this purely using happy? And I think there isn't. I think there isn't just because it would be valid, I think, in a Rust-like language like ours, to have an if expression and for the expression to contain braces if it's a struct expression, because after all, we couldn't be constructing a struct and then getting a field out. That's a perfectly valid expression, and we would not be able to identify that it is. So, what solutions we have? We could modify the grammar of a language to remove the ambiguity. By forcing parentheses around the expression in an if and in an if, basically, and a while and a for, I guess. Because I can't say always reduce. That's not true. Yeah, I think I have no choice but to modify the grammar at this point. Unless, could I modify the precedence of no, because again, it would be valid to have an expression that contains braces. I think I have to rewrite, I have to change this. I have to change the grammar of the language, which I am not super happy with, but that's not the end of the world. I have somewhere for expressions a grouped expression. I can force my if, else, and while to take a grouped expression. And now the shift conflict is still going to be there, but there is never going to be an expression anymore that is going to be followed by an open brace that should be passed as that's the end of the expression, that's an opening brace. Therefore, default to shift is correct. Ah, that's ugly for 4. That's ugly. There's another possibility. There's another possibility, which is that no, I don't think this possible. Yeah, it's ambiguous. If I do a 4x in a open brace, that's just gonna be passed as a that is just gonna be passed as a struct expression. Is there a possibility, however, that before I commit to this, can I change a struct expression instead? Because that's a path expression followed by this. Could I change this? What is it in Rust? It's a path in expression. An expression. Yeah, I guess that's a solution, which is to introduce a different syntax for structure construction, and then it becomes unambiguous. We do the same thing for type arguments, so after all, why not? Maybe, I think if I do this, yeah, I think, especially since struct are not going to be that common in the language anyway, if at the end of the path expression I force a double colon like this, that's path colon open the braces, then that is never ambiguous anymore, I think. Nope, still one shift reduce conflict. State 33. Ah, that's because the same syntax is used for something else, I think. Let's see if that's a real conflict that's gonna arise. What is this? Yes, I cannot differentiate between the generic arguments and state 35 would be, yep, or reduce using rule 61, and rule 61 is probably our newly introduced version of a structure. No, it's just, yeah. Aha. I don't want to force parentheses for if, else, and the others. I think that's inelegant. Especially for 4. I want to be able to say for x in L and not have that be like 4x in bracket parentheses L. That's ugly. So I don't want that. So that means I need to find a way to express structure expressions as the choice to use Alex and Happy for this project was deliberate, but has been a pain in many ways. Because here, if I were using parsec, I could just try one, realize, oh, the thing that comes after is not fields. That's not a struct expression. That's a block. Pass this as a block fairly easily. But here I'm limited by what this grammar can describe. That is a pain. I can't use parentheses for struct construction because then I would not be able to differentiate that with a call expression. That being said, that would kind of be the C++ syntax there. And I could pass that as a call expression. And when it's a call expression, if I recognize it's a structure name rather than a function name, then that's fine. That's an option. That's not a very good option, but that's an option. On one hand, I'm glad the test caught this. On the other, this is annoying. What do I want the language to look like? Like if I do a let s equal customer of int, right now this has to be this. Or something like that. And this is ambiguous because I cannot distinguish between this expression, which is a path, which could be a constant or something, followed by a block, and just this being a struct construction. Okay. What do I decide is the correct syntax there if there is not a way I can differentiate using I mean, I can choose whatever I want. I could have the I could have the syntax be construct with something, but that's ugly as hell. I guess I could use this. That is unique. That's weird. And my only issue with this is the reason I chose to base the syntax of the language on Rust was that syntax highlighting and formatting tools will work out of the box on our fake language. If I do this, if I introduce something like this, that suddenly is no longer the case. At the same time, I don't see a lot of other options. So could I rewrite my rules to avoid this? Is there a way that I can reliably distinguish, given the context of something, whether I don't think so. I don't think I can. Yeah, I guess for now, for the sake of making progress, I am gonna use this syntax. I don't like it a lot, but it's better than not making progress. So we are gonna have to make a few changes. We have a new operator, which is the operator at. Our Alexa is now recognizing a new operator. That's also the thing is that's also the fact that I'm working on a made up language where I have no constraint other than the ones I have decided for myself. I can just change the syntax of the language. If I couldn't, how would I fix this? I think the answer is at this point I would just ditch happy and rewrite everything with megaparsec, which I might at some point do nonetheless because working with Alex and happy has been fairly unpleasant. I mean, it's been interesting. I don't regret doing it, but the limitations have been very, very annoying. And the Rust compiler is written with basically parser combinators in a parsec-like fashion. Okay, but for now, let's use this. Let's use this made-up syntax. I could always do a version 2 of the language. Although I'm not happy with this. Now, parser, here we have this. Oops. And this is used in only one place in a struct expression. And here at the end of the path expression, we have the at. That's not very elegant. I think at this point I will just rewrite all of this with megaparsec, but not right now. So here, when I am printing a struct expression, I have to do this. There we go. I will now remove the golden file. And we can try again. Oh, also, of course, I should try first. And now we are done. We no longer have any shift reduce conflict. Okay, and of course, one last thing to change. Here I'm using $1, $3. This is no longer $3. This is $4 because that's the fourth thing in the list of things. Yeah, I think before this goes to 1.0, which is months from now, I'll rewrite this with megaparsec. I'll get rid of happy, and I will, as a result, fix this to no longer have this weird syntax and have the same proper syntax as Rust has in this case. And because I don't like introducing weird syntax just to make happy. That feels wrong. Okay. So now what is wrong with this? Missing semicolon. That is correct. Okay. Interesting. What is wrong here? In the golden file that has been generated in the previous run. Oh, it was empty because the run failed. That makes sense. And now the tests are passing. I'm just going to rerun a few times just to make certain that quick check doesn't catch anything else. But now that we have corrected all of the errors in the pretty printer and we have fixed the last shift reduce conflict in the grammar, I'm fairly confident that we are done. Okay. Well, I mean, most of the bugs we found were not the result of the change to the AST structure. They were consequences of the fact that the tests were incomplete. So, not new errors, old errors. But now we can move on. Since we have the new AST, we are done with all of this. I can start work on the analysis phase. I'm not going to make a lot of progress this evening because it's getting late, but we can still get started. Okay. So for now, let's make it in this file and we'll break it down later if needed. What is going to be the role of this phase? This phase is going to take the AST that we have passed, and it's going to do basically everything up to, but not including, lowering into the AR. So that means doing the name resolving for each name that appears in an expression, in a declaration like a type, a variable, anything. Where is that name coming from? Is it in scope? Type checking. Hey, this thing needs to have a type. What is the type of that thing? And I mean, just doing all of the checks basically. The important bit is, in theory, after the output of this phase, if this phase succeeds, there should not be any error from that point forwards. Any error from that point, from after this phase, is an internal compiler error, not a user error, because this phase is where we validate the user's input. So, analyze is going to be a function that's going to take some kind of context, which is going to be the modules we have already compiled, I guess, which means the caller is going to be responsible for like a given module to make sure to check the imports and make sure we have compiled those first. So that's going to be, our context is going to be a hash map of module name, whatever that ends up being, to the contents of that module, which I think I'm going to call the symbols. Even though that's not something that exists yet, I'm shaping the whole thing and then going to fill in the details. That's the context in which we operate. Those modules are the ones that were accessible to us. That's the one we have already compiled. Then we take our module, which is the thing we're going to be compiling, well, analyzing. What is the output? The output is a list of diagnostics and maybe the transformed AST. And the reason I'm doing this, I could do with these with either, but I would need to check the validity of like all of them are warnings. Yeah, no, I think it's the easiest. It's the easiest. The output of this is a list of diagnostics, which may or may not be empty, and maybe symbols, the symbols that map to that current module. That's not all we need. No, I was gonna say we need the module name. I think we don't. I think it's fine. No, actually, I think we need the module name. I think I need to be able to put the canonical name of something. Like for instance, if I have a function in the same module, I have a function foo that calls a function bar. I want to be able to say that the bar that we're calling is the one in the same module, but I don't want to put that as a relative thing. I want to put it as like the name of the thing I'm calling is the bar thing in that particular module, and use an objective and what's what I'm looking for? Not a relative path, basically. So that means I need to know what the module name of the thing I'm compiling is. And we return a list of diagnostics, warnings, and errors that we have encountered, and maybe the symbols that map to this thing if we successfully analyze the whole thing. Okay? We are going to need to define a bunch of things because none of this exists. I'm going to call this the context, the module name, the module. Module is a keyword. I cannot do that. And what is this going to be? I can already define the shape of this function despite not having defined half the types that are involved here, because this is gonna be traversing the module with basically iterating on each declaration in the module, because symbols is gonna be a hash map of identifier to declaration, basically resolved. And because everything is just the imports I no longer need. And the process of doing this is basically gonna be to collect, to traverse. It's going to be traversing each declaration on its own and then concatenating the results. I can probably be smart and try to compile everything, every declaration at the top level in the file, which means if there is errors in the function, even if I can't continue and I have to stop trying to analyze this function, I can still analyze the next function and therefore try to find more errors. So this is gonna look like I am compiling a made-up language that doesn't exist, very inspired by Rust. I basically, except for one change I've made this evening, the syntax is the same as Rust, but like a very, very small subset of it. And the point is, I am taking this pseudo Rust with, generic type arguments, the whole thing, like still like a fairly like complex language. And I'm compiling it to Piètre, which is an esoteric language in which the source code is an image. at this point, we already have Lexa parser. I've used Alex and Happy, which are the standard parser generator tools for Haskell. So generating a Lexa, generating a parser from a set of rules on the grammar, which is the choice that I made on purpose because those are standard tools in Haskell and I wanted to use them, but that has been a pain to work with. And I have already done the end of the no, probably not. At least not in the first version of the language. And we've already done the end of the process, which means given some bytecode, which is basically Pete instructions and a tiny more things, we are now already able to generate images. For instance, if I open, I think it's called just test.png. It's very small. Let me send this. This is the worst possible viewer for this. Do I open it in GIMP? There we go. This is the first Pete program we have generated from bytecode manually. And that's this small program does one thing: it prints a star and it prints a new line, and that's it. But it already shows the way we're going to be structuring the output. Like this, again, this linking, assembling part at the end of the compiler, the backend part, done. And that's basically, yeah, tiny bit, you're right. That's the entrance block that looks a bit like this. You can see the structure where this strip at the top is the one that distributes. When we have an address for a goto at the top of the stack, basically checks whether the address is within this function. If yes, goes here and enters the function. Otherwise, subtract the number of entries and continues to this next strip that does the same thing. And each of those is a function with several entries here for each label, like entry point to the function, because we support gotos and stuff. And then this is a series of instructions. And when we exit a function, we do a loop-de-loop here to then go to the back of the image, to then loop here, and go back to the thing here. So this function does the entry, pushes the arguments of like, we are going to address to, sorry, our return address for the function call is 2, the function address is 3, go to that, which then leaves this function goes to address 3 here, which does like a bunch of integer manipulation to then print those values. Then at the end, we exit. We have the return address at the top of the stack. We go back to here. The return address is 2. This is less than 3. It goes here. 2 is this one. And here is the terminate block that stops the execution of the program. So we have that's basically the structure of how we're going to generate Pete programs. So now we have parser into AST, bytecode into image. What we're missing is, well, sure, we have the AST, and how do we get the bytecode now? So now we have to do, like, we have started working this evening on the analysis phase. After that, when it's done, which is not going to be this evening, we're going to move into the lowering into IR, and I want to do a static single assignment IR that is basically a much simpler version of the LLVM IR, because I want this project I'm taking as serious as I can, and then from that we'll be lowering into the bytecode that already exists. It's going to take months. It has already taken months. It's going to take months. It's a long project. But yeah, that's the project. And I have a bunch of side goals I want to tackle at some point. One such goal is, given that our IR is going to be somewhat similar to the LLVM IR, exporting from our IR to the LLVM one, doing a conversion of like from a subset to the full thing, should not be too complicated. Famous last words. So having something that takes our made-up Rust-like language and then compiles it into an actual binary to test, to compare the implementation of the binary versus the Pete interpreter, could be an interesting thing to do. I have, well, yes, but again, as a side project, because the real cogen is the Piètre image generation. So, back to the analyze thing. Here again, I'm defining the extremely high level thing. Half the types I have declared here don't exist yet. This doesn't compile. I'm just thinking out loud about what the shape of this is going to be. So symbols is going to be a hash map of... Well, the thing is, again, I'm not going to use LLVM for the image generation. Unless you meant image not in the image sense, but image is an overloaded term. Do you mean the binary image or the Piètre image? Because for the Piètre image, I'm not going to use LLVM. This is going to be entirely in-house, like full code that we do here. I am, as a side project, might also do LLVM codegen to generate binary image to just be able to compare from the same IR which one, like check that the behavior is the same from the interpreted image and from the executed binary image, basically. So here, given a module, we have a bunch of imports. The imports are going to be used to construct the first top level scope, which is going to be used to check, to do the name resolving of every declaration within the file. I'm going to put the compiler away for now. Let's go back to the AST so that I know what I'm dealing with. Okay. And so I'm going to use the imports only to decide what my scope is, my top level scope, my top level context. What I want to do is basically... I can't do it in parallel. Oh, I can, but my top level scope needs to contain the name, because I want to do the same thing that Haskell does. Thank you for tuning in. And yeah, again, I'll publish all on social because I haven't done it yet, but I've started a second channel with the entire history of the streams of the project, the bad ones and the good ones. Yeah, again, tokenizer done, parser generator done, passing into an AST done. At the other end of the pipeline of the toolchain, bytecode linking the bytecode, assembling the bytecode into an image, done. Now we're missing all of the middle, which is the interesting part. But yeah, since I want to do the same thing as Haskell, where the order of declarations within a module doesn't matter, as in if I have within the module a function foo and then a function bar, foo is able to call bar, that's fine. That means that my scope needs to be initialized with the name of the top level declarations. But that's fine. Within a declaration, I think the order in which I process them is irrelevant. Well, actually, it's more like I can process them in parallel, kinda, and it doesn't matter. So what this is going to look like is... No, there's one thing that matters, is what if I have conflicting names? What if a file contains several declarations with the same name? It's going to be detected at the start when I'm creating the scope. Therefore, I can assume that the core of this function is going to be a map of Go on the declarations, where Go, or rather maybe I'm going to introduce analyze declaration, rather than having this be a separate... do I want that to be... No, I want to have analyze declaration be... Yeah, I know what I want to do. I'm going to explain as I go. Go is going to be my top level wrapper that runs the monad in which I'm going to do the analysis for the thing. And then I'm going to have each function for... Yeah, I'm not sure I want to actually parallelize this. I mean, I could. That would be an interesting optimization. I don't think there would be any issue with this, since each of them is going to run into a separate context, but probably not worth doing. Actually, maybe it is. I'm not at the point where I'm going to benchmark code that doesn't even compile yet, but something to keep in mind. So Go is going to be given a declaration. I'm going to want to analyze this and then run the underlying monad. Ooh, fun. I need to do more Rust. I know a lot about it, but I have never written any large project with it. So what is going to be, I'll actually give the type of this. This is going to be given a declaration that happens to be in a past state. I want to return a list of diagnostics, and maybe, and in this case, so symbols is going to be a hash map from identifier to the declaration of the thing. So to initiate the hash map, this is going to be a key value pair, therefore the identifier and the declaration resolved. And to do this, this is going to be doing analyze declaration of that declaration, and the result of which I am going to do. I want to keep the state. Yes, because the underlying monad will contain all of the diagnostics as part of a writer monad. So I probably want to do run maybe t on top. That gives me the maybe value. So if at any point something goes wrong, I can just short circuit and get a nothing. And I can do then a run WST, RWS, because there's no underlying monad. I'm not operating in IO. I don't think I need IO for this. So that's just run RWS. And run RWS takes the expression first. Okay. That is annoying, but that is how it is. There is no version with the arguments flipped. That's annoying. Okay, so let's rewrite this. This is going to be... Actually, run RWS is going to give me... I have no choice. I'm interested in the value and the writer, but not the state. And there is... Oh, there is. Eval. Perfect. Because that's exactly what it is. It's going to be... except it's going to be the other way around. But W, the writer, is going to be what we write as we go, which is going to be our list of diagnostics. And A, the value, is going to be what is returned as the last value of the expression. That's going to be this tuple here if everything goes right. So this is going to be a flip of eval RWS of some expression here with the reader, the initial reader, the initial state that we have not defined yet. And here, this is going to be a run maybe t of analyze declaration of D. And those are things R and S. Just gonna rewrite it that way. Are gonna be the two initial values. So this is gonna be, I'm not gonna call it context because that's the name of the modules here. So what is gonna be required? I don't think the module info is gonna be required. That's gonna be part of the scope. I think the only thing that's actually needed is the module name as part of the reader, because everything else is going to be in the state in the scope, because that is going to change unless no, the scope has to be the scope has to be something that changes over time. So it's going to be initial scope, which is something that I'm going to keep track of separately. Okay. So that is going to be the shape of this function. I can remove this now. And again, even if none of those types exist, I can still already write something like analyze declaration, which is going to be, and I think I want to, actually, I could simplify this by introducing my own monad rather than dealing with a custom stack. This is, yeah, I have full control. I don't need anything else. And this is going to be, can I write it in the shape of the thing? I've done this in the past. And then use the deriving via to avoid having to have the full stack and just inline it in cell. It's inline it instead. Because this is, I can see the source. I can't see the source for this one. Is it because it will be here? No, that's not what I'm looking for. I am looking for the definition. It's not there. Is it because it's defined? It's probably defined as transformers. Yes, that's where it's defined. There we go. So that's where it is. I'm gonna copy this. Except here I can hard code R and S to be whatever I want. Which for now is going to be module name and scope. Yes, switching to Firefox and suddenly. And the result here is going to be some maybe A, because I'm operating in maybe T. And the state at the end is going to be the scope. And the W here is going to be the list of diagnostic. Oh, here I have diagnostics plural. That's incorrect. That's a list of diagnostic. There we go. And I think I've used this construction. I'm in the Haskell cult fully. Haskell is my main programming language and has been for main probably 5-6 years, and I've been using it regularly for a decade at this point. I am fully. I have used it professionally from 2020 to 2023. My job was a fully Haskell job, and I miss it. It was great. I'm currently like looking for a new job. If you have Haskell jobs, please send them my way. But yeah, there are few jobs, but there are some. The problem is like for a while, the monkey paw of Haskellers wishing for Haskell jobs curled, and for a long time the only Haskell jobs were crypto related jobs, and that sucked. That was bad. But yeah, no, I got the chance to use Haskell professionally for 3 years, and that was a delight. And I would really like to be able to find that again because I've had Python since, and just no, please, no more Python. So what I'm missing here, I wanted to go back to the parser that we have defined in the parsing stage because I have used this trick here. That's the wrong file. I made this file here where I do the same thing. I inline my stack of monads, and then in the deriving, I do the via to use the thing that I need. So here, let's do the same thing. This analyze m thing is, should I put it on the new line? I'm a Haskeller, so, take that with a grain of salt. I am very, very strongly on the side of like a strict compiler that will be a pain in the ass, will save you down the line. Anything that it can catch, is errors you don't have to face at runtime. And I have worked with enough Python to know that like I want a tool smarter than me to catch all of my mistakes. So again, I'm a Haskeller, so I'm biased here. So this is a monad. This is a monad state for a scope. It's not a monad error, actually. Because monad error implies we can short circuit by throwing an error. This is not how we're going to do things because we want to be able to handle warnings. So this is instead going to be a monad maybe, or whatever it's called. Let's have a look. Where is maybe in this? There we go. Is there a class for this? I don't think there is. That's annoying. That means my plan to just use to inline the monad might not work because there is no way for me to express the constraint that this happens. Yeah, okay, no. So I am giving up on this. Monad reader of the module name. But will maybe T still work if I'm in a new type? Or will I have to do some wrapping myself? Maybe in this case, I should not do a new type and do the whole thing. Maybe since I want to use maybe T, which is slightly constraining from that perspective, I can just do a type alias where this is a maybe T of A, and I can probably omit this, and this is an MABT of an RWS where the read is module name, the state is scope, and the W is diagnostic. Now, the point of having this go here function that like does all of this is I can now I do all of the unwrapping of everything. I'm looking at your Rust conversation, but that this is beyond my Rust knowledge. So this is going to be rewritten as this takes a declaration that is passed, and it returns something within our analyze monad. And what it returns is, upon success, a declaration that is resolved. Everything else, the diagnostics and the fact that this might fail, is all handled by this type here. Okay, this I'm gonna leave undefined for now. Now, what I need to fix here, I'm doing this go on all of my declarations. So for each of them, I run the analysis, I unwrap the monad, I do the whole thing in its own separate context because there's no need to have shared context for this. As a result, I get here a list of tuple of diagnostics and maybe pair of values. I'm going to want to unzip this. So unzip, given a list of pairs, give me a pair of lists of each of the arguments of the things. So on the left-hand side, I'll get all of the diagnostics concatenated. On the right-hand side, I will get a list of maybe of the tuples of the analysis. So that is going to be diagnostics and symbols. That's going to be the result of doing this unzip of map go of the declarations. And what do I do with this? I'm going to return the concatenation of the diagnostics because I'm getting a list of lists, so I just concatenated that. And I think I have a list of maybe things, and I want a maybe list of things. I think that's just a sequence. I can try that here in GHCI. If I sequence a bunch of maybe just three, just four, I should get just the list 3, 4. And if I add a nothing, I will get nothing. Yeah, that's correct. So that's sequence. That's sequence of my symbols. And now I have the maybe association list tuple key values, and I can do a hash map from list within the maybe. There we go. Just maybe M. Ah, thank you. Strict qualified as M. Have I used a different naming convention so far? For my imports? No, that's my usual naming convention. Okay. Symbols, thank you. Okay. So that should be correct once the type are defined. Even if for now module name is string and I should probably define module name properly at some point because string is completely wrong. Okay, I guess I can do that because otherwise this should be valid if useless. Go back to name. Yes, not great. Module name, string. The output of this is going to be symbols, which is a hash map from identifier to a declaration resolved. Okay? This is missing one thing, I think, overall. Oh, it's missing diagnostic. I don't yet have. My error handling so far is abysmal because the errors of Alex and Happy are pretty bad. And I have not made any attempt at making them better. However, this is where the interesting errors are going to be. So maybe I should do something. I should prepare and have warning shadow something. I will take some arguments. And something like error duplicate name, whatever. Those are just completely, but just to have something. Okay. And last but not least, we will need to have something that, given some context and a list of imports, computes the initial scope. So that's going to be the top level account type. And this is going to be the internals. And here is where I'm going to need the initial scope. The initial scope is going to take as an argument the hash map from module name to a bunch of symbols that have already been resolved by compilation of other modules that we depend on. Then I will get as a second argument my list of imports, which is a list of import. And this is going to give me a scope, which is not something we have defined yet. No, this is going to give me either a list of diagnostic. No, that's not true. This is a tuple diagnostic maybe scope because this might fail. Aha. We haven't decided what the scope is going to be, but the scope is going to be some record that contains stuff that we need to keep track of. And I think the very, very basic information of this is going to be a scope names, which is going to be, it's going to be a hash map from identifier. Given the name X in the current scope, what does that X mean? And that's going to be a name and maybe a declaration resolved. Which is going to be tricky with the fact that I'm going to need to create a fake declaration resolved for my top level functions of my module, I think. And it might contain some other stuff. We'll see. Okay. If I'm using lenses for this, then suddenly the order of declarations in this file is going to matter. That's going to be annoying. Oh well. Not going to be the first time this happens. I guess I could write them manually and avoid template Haskell. Let's not get ahead of ourselves. Okay, so it's going to be something along those lines. The initial scope is going to be computing the full set of like things that are in context. Oh, but do we want to do that? I don't think we want to do that. Because it's fine to have conflicts as long as I never, if I import a module A and a module B and they both define something called foo, as long as my module doesn't call foo, it's fine. That's not a conflict. So if I were to create a full hash map of the scope from the start, from the get-go, I would try to say, well, foo in this context means this, and that would be a problem. So maybe I should not eagerly construct the hash map of the scope, but instead lazily do a lookup in each thing. That being said, this might be a bit slow, so perhaps I should do it and keep a list of possibilities for each of them, a non-empty list. And in the case where I am trying to call something that has a name that is... Yeah, I think that's the right approach. I can do that. I can create a cache of the scope, and it contains a non-empty list, but it can be overridden because I can shadow names from other modules, which would be a warning but not an error. And therefore, when I do a lookup for a name, I look up in my full cache of hash map from identifier to thing. If it gives me no entry, that name is not found. If it gives me more than one entry, ambiguous, it gives me one entry, found. So this scope names, instead of being a hash map identifier to this, it's going to be a hash map identifier to a non-empty list of, maybe I'm going to use a type alias for this. Scope info, name info. Nah, I think it's fine to just inline it. There's no point. This is a tuple of name and maybe declaration, because not everything will have a top level declaration. Like variables in A4 perhaps won't have that. But maybe instead I will want to replace this maybe with an either that for a local thing gives me some amount of information. Okay. Still undefined for now. What else am I missing? Yes, this initial scope function might fail. We might fail to create the thing if, for instance, the top level declarations in my module conflict. I have two of the same name. So this might give me some diagnostic. I might be running in a maybt as well. That's probably going to be the right approach for this. And as a result, I'm going to need to handle this properly. Because initial scope is not guaranteed to exist. So this go needs to take the scope as an argument. So I'm going to rewrite this to not be a bunch of where, I guess. Because it depends on... Can I rewrite this to be? Can I make this somewhat monadic is my question. Because I guess it is a maybe t on top of a tuple. Yeah, I guess I can do that. This is a flip of run writer of run maybe t of do something, which I can put here and then start here. And in this do block of my maybe on top of a writer on top of the thing, what do I do? I get the initial scope by calling initial scope of my context and my module imports, which I am going to rewrite to instead be in some custom monad. So this is going to be in a maybe t of a writer diagnostic of scope. There we go. This gives me the initial scope. I can then do this thing right here. That's kind of ugly though. I'm running. Yeah, it's fine. It is fine. It just means that here, instead of returning the tuple, I am going to be doing a tail of concat of diagnostics to put them in the output of my writer. And then I will do, if I've made it this far, I'm gonna hoist maybe of the sequence of the symbols. And if that worked successfully, I am now in a context where I have a non-nothing here. I can return from list of the symbols list. And I can remove this and keep the go thing that tells me how to run the monad for a given declaration. Okay. I think I've defined everything at this point. This is still doing basically nothing, but the shape of it is there now. And let's see what breaks. A bunch of things, I'm sure. Identifier that define. I should, at the very least... did I have... Yes, I have this formatting. Okay. I should, at the very least, have the AST in scope, and I think I will need tokens for the identifier. And I will need name for names. Diagnostic is not defined. That is part of stages, analysis, diagnostic. RWS, interesting. I thought I had it in my prelude. I don't. Fascinating. Do I want this strict? Probably. I'm not gonna do anything complicated in terms of like knot tying and like circular definitions. So I think it's fine. Do I want to import it qualified or no? I think it's fine. And I need control on that writer as well. Expecting 2 more arguments to state. Yes, state is not a thing. Scope is a thing. Variable named scope host maybe. That is coming from control monad trans maybe. There we go. Actual errors. I have something here that's not applied to enough arguments. So run maybt given a maybt expression gives me an m maybe a. That's fine. That's correct. And now what does run writer give me? It doesn't take any argument and gives me run writer gives me a tuple a w. That's fine. And then flip should flip those two and give me. Is it because? No. Okay. Oh, that's because flip is not the right thing. I'm using flip as if it were a way to flip a pair. That's not what it is. Is there? Because flip is from a function ABC make a function BAC. What I want is swap. It exists. Data tuple. Okay. Is there another place where I have a flip where I meant to swap? Here indeed. Okay. Next. Map go this fails. So it expects a with location declaration passed returns diagnostic maybe identifier declaration resolved. Actual oh, because go needs the scope as an argument. Because the scope might not exist if we have failed to create it. There we go. And initial scope here doesn't make sense. That's just the scope. Okay. And I think this should be a with location declaration passed. Which I could rewrite as an annotated, but might as well not do it. This is going to require location to be in scope. There we go. Interesting. I have something wrong somewhere. Yes, this should not give me a declaration resolved if it works. It should give me an identifier, a pair of identifier and declaration resolved, which is the key value pair, which is going to be then used here to create the hash map of the symbols that are the result of our analysis phase. And that seems to compile. Okay, so our top level structure for the analysis is there. Now, what? Oh, it's late. Maybe I shouldn't push too much. I've been streaming for 4 hours and a half. Yeah. At least we've made. I mean, technically we have less code than we had on Tuesday evening, but we've cleaned a lot of things. We have a clear direction for a lot of things. We found a very important and annoying bug in the parser. We've improved the tests. We haven't a lot more code, but we're in a much better situation than we were 4 hours ago. I think I'm not going to start attacking the meat of the analysis this evening because, again, 4 hours and a half in and I haven't had dinner yet. I should probably not push a lot further, but I can continue doing the high level structure of this and I can continue doing the high level structure. And I'll fill in the blanks next time. So the thing is, in the case of a declaration, I don't really care where it's declared. At this scope, I'm gonna just give that information. Oh, maybe would that make sense to store in the reader state? Like we are analyzing something that happens to be at this place. So that rather than giving a location argument to all of my function, like, hey, we happen to be analyzing this thing at this place, would it make sense to instead put that in the scope, in the state of our monad, or maybe in the reader, so that at any point I can ask, hey, where am I? What's the location of this thing I'm currently analyzing? I wonder if I will ever want to implement some kind of limit of diagnostics. Like past 20 diagnostics, don't worry outputting anymore, or something like this. I don't think so for now. If I write something very bad and it outputs 2000 error messages, that's fine. But okay, I think I don't dislike the idea of having the current location in the scope, in the monad at least. Maybe not in the scope, maybe in the reader. Because that way it's that much that I just don't have to pass around manually. Every time I encounter something with an expression, I just set that location within the reader and I continue doing the analysis. And that means I'm not passing I'm not passing the location explicitly, but my error handling thing, my reporting function, can be like, give me the location of the thing, and I know exactly where I am. Yeah, that feels like a correct approach to this. Now, can I make a type class so that I can write a generic analyze function for with location of something that just delegates to the underlying thing? Or will I have to write it 3 times manually? 3 times? Surely it's worth spending 5 minutes to avoid having 3 different functions where I could have one. I think it's possible, yeah. I could do that. Let's rename this one run analysis instead of run analyze. And let's make... I have learned nothing from what we did earlier this evening. A type class that's to a given type of the AST T associates an output type, which is basically gonna be the thing but adapted to be the resolved. But that way I have some flexibility. And an analyze function that is gonna take that thing and return an analyze m, which I could at this point inline. No, because I'm going to have helper functions. An analyze m of the associated type. There we go. That means now that I can say the instance of analyzable... Is that the proper spelling? Yeah. Of... So if something is analyzable and I have a with location of that A, I can make an instance where the type location of A is an analyzed with location. It's a with location of analyzed of A. And analyze is, as an argument, I'm getting a with location with 2 arguments. And this is going to be update the reader context. So it's going to be a local that's going to modify the current context of analyze the current thing, which is so located and local set location, I guess. Something like that. I'm going to have to change here. I have a scope. I'm going to change my my reader to be a context. And a context is going to be a thing I'm carrying around that has the module name, something that's never going to change across the thing, and it's going to have the location. I think I want to put it in a reader despite the fact that it changes, because it's always only ever changing for a sub-expression where local makes sense. So context location, which is a location. And I will want to have lenses for those, which is going to be a pain, but that's the pain that's going to be for later. And so here, this is local set location of analyze of the located, and set location is just lenses for the win. This is going to be context location dot equal. Actually, is there even better than this? Lens getter. Is there an equivalent of local because view is something for another reader. No, there doesn't seem to be an equivalent for local. Okay, that's fine. Yeah, that's gonna just be location. Okay. So here, this is no longer gonna be module name. This is gonna be I'm gonna have to have some kind of debug location. So I'm gonna delegate that to another function. Initial context, much simpler. Takes the module name, returns a context. Initial context is just a context in which we are gonna give a location. What is the location again? That's initial location. I probably don't need a function for this. I can just probably initial location. Oh, but this requires the file name. That I don't have. I can cheat. I can cheat a tiny bit, which is a bit ugly, but I can set this initial location with an empty file name, because whenever I'm going to encounter a declaration, so whenever I'm going to do anything with this, I'm going to use a local to set the location to the actual location of the declaration. So I think it's fine. Okay, there we go. So I can rewrite this analyze declaration as instead being an instance of the analyzable class. And the associated, so this is going to be a declaration passed. And the associated type will be a declaration resolved. And analyze is going to be this undefined thing for now. And now the rest of the top level structure is just going to be defining this analyze function for all of the types of the AST, basically. And the upside is now, instead of having to say analyze declaration, analyze function info, analyze, I just call it analyze. It delegates the right thing. If with location, it does the right thing at every level. That's a lot easier. And now that becomes a simple case. Could I use this logic of having a class of something that is able to, like, can I make a pseudo traversable for my AST basically, so that I write once this thing of like apply the function at every level, replace the value with whatever, combine and like return the same thing overall? It's tempting. It's tempting. But even if I do that, I would still have to do. I would still have to say the function I'm applying at all of those levels is analyze, and I would still need to do this. Yeah, I think there's no. I've been trying to think about a way to just avoid having to write this, and I don't think there's a simple way. So in the case where I have this, the result is gonna be applying the same constructor in the result of analyzing said info. Okay. Next, what do we have? So here I'm gonna have to declare for all of those. Can I generate this file based on I probably can. If I do this. If I do this and that and come back here and keep lines containing the regex deriving, can I do? I have deriving instance, a bunch of stuff I don't care about, show, and the name of the type. And I can replace this with instance analyzable this type of past, where first line is going to be type analyzed, the type past is the type resolved, and the second line is going to be analyze equals undefined, and I'm going to insert a new line for good measure. There we go. Perfect. I'm going to keep all of the ones that are info undefined for now. Yeah, it is. And in multicursor editing and replacing regex with preview, just, yeah. I'm going to leave all of those undefined for now because this is the thing I'm going to do next time because it's starting to get late. However, there's a few things I can do, and the ones I can do are the ones that have like a case like this. The one that are like basically statement and expression. I can do that. So how do I analyze a continue statement? That's going to be interesting. There's no type associated with it. I'm going to have to do some magic there. Well, magic, no, but so statement here. This is going to be case of one of those. That's info. Um, I guess all of those are gonna need to be handled specially. So yours is a tiny bit more verbose, is what you're saying. Yeah. So here, I don't have a type I can delegate to the analyze to. I'm gonna have to do. Maybe I'm wrong with this approach of the type class. Maybe that's the wrong approach because maybe I want to analyze things in context and doing so deprives me of the context. I don't think it is, but maybe I'm wrong. We'll figure that out next time. So return statement, this would be red val. Continue statement and break statement. There is not a lot to analyze except are we in a loop, which is something I'm going to have to keep track of in my scope, basically. And for all of those, this is going to be and with those constructors added at the beginning, because we are f mapping this onto the result. Okay. So that's the second of our big case of we're splitting this based on constructors. Declaration statement, and the last that we're missing, and that's going to be the last thing I do this evening before testing that it compiles and then stopping for the evening, is going to be the same thing for expression. Except, do I want to just say no, I don't think I want to do the same thing for expression because I think a lot of it's going to be on a case per case basis. Give me the analysis of the underlying sub expressions and then perform all the checks to make sure that they are correct, which will include type validation and everything, which is not just a analyze this if thing and just rewrap it afterwards. So I think expression is going to be a bit different. Although there's probably going to be some helpers there that are going to be useful, but I can write this big case statement. Oh god. It's going to be a monster. Oh, actually, I am wrong about something, interestingly, that I need to change. What I'm wrong about is that the output of a with location is just the analyzed thing. We're not keeping the location in the output. That's one of the things we did. Ah, this hard codes. This hard codes the idea that we're removing the location for all three of them, which is not true. I guess no. I think that's fine. I can handle this on a case by case basis. I think that's fine. So now I just need to name all of those. That's a path. That's an expression and an identifier. That's a name, and that's a path, and that's arguments. That's an array. That's an expression, that's an index. That's a path, and that's fields. That's just a reference to a path. That's an expression. Those are exprl L and exprl right. A cast is an expression and a path. And those are back to being exprl L, exprl R. Tempted to just move the cast here. There we go. Okay, that's their names. For now, those brave things are all gonna be undefined. Okay. That's the rough structure. Let's see if this compiles. And when it does, I'll stop for the evening. Analyze declaration doesn't exist. It is now called analyze. Match declaration resolved. Map go scope. Yes, analyzed with location declaration passed. That should be a just declaration resolved, because analyzed of declaration passed is declaration resolved, and analyze of with location of A is the analyze of A. So what's the difference here? Here it's expecting from a with location of the past declaration, return a tuple of diagnostic, maybe tuple identifier. Aha, yes, indeed. When I'm analyzing a declaration, the result is a tuple of identifier declaration resolved. So here, probably something from the info. Oops. Your name. Context location, that's because I have not declared. I think given how much of a nightmare it's going to be for ordering of functions if I have to put the lenses in this, I think I'm going to split this file. Analysis will therefore now contain a monad file that will contain just this basic stuff. And import control.lens. Make lenses of context. Make lenses of scope. So we quarantine the monad to this. I'm gonna need a few of those imports. Let's import everything and sort out afterwards. Okay. Do I want to introduce while I am while I am at it a run analysis function that, given a scope and a module name, a scope, a module name, or rather the module name first, I think makes more sense. Module name, scope, and an analyze M of A gives me a tuple diagnostic, a pair diagnostic maybe A. And run analysis, I'm gonna duplicate, well, copy and change. That's gonna be based on this, basically. This is going to be, given the module name and the scope, it's gonna be this swap of eval RWS, where the monadic expression is run maybe t of analyze. No, wait, no, that's fine. This is of the action that is given as an argument. This is diagnostic. This doesn't require knowing about analyze at this point, where the context is module name and initial location and the scope. Okay. So with this now here, I can rewrite this to not have a go function. This is now map run analysis module name scope. There we go. So that's part of it that has been extracted. Do I want to extract this analysis part, or is it still fine here? I think it's still fine here for this evening, at least. I probably want to move it to somewhere else. But I'm not gonna do that now. I'm gonna just need to import monad from here. I forgot to declare language template Haskell, which is why I've isolated this thing to a small file so that only a small part of it is affected by this. And the only thing I need is make lenses. Redundant, okay. Control moderator is redundant, okay. Wait, I have another thing called run analysis in another. Yes, right here. I'm not great at naming things. How do I want to rename this? Maybe this is the analyze module function. Ah, yes, of course. And this is analyze. Ah, that's where it is. There we go. Do I instead use a do block for this? No, I think it's fine. Okay. I am going to need control.lens for this, as always. Rising from a use of local. Okay, am I using local wrong? Monad reader. This is a function that takes, okay. So I am in the context of my analyze monad, and local should work. Maybe it is because I forgot to say that this. Oh, wait, no, because it is an RWS. It has access to local. Why does it believe that this thing, which is indeed an RWST of context over diagnostic scope identity, has a constraint of reader on this? That's peculiar. Is there a place where I'm making the mistake of giving it an empty tuple and it's getting very confused? Is it because I'm using the wrong lens operator? That's also a possibility. Oh no. You can't see it. There we go. Um, I used to have a local copy of the documentation on my machine. I don't, I think. Do I? When I worked on the other project I was working on, I used to write. Do I have? Nope, that is only the documentation for my own stuff, I think. No, I don't seem to have. Would I have a cache? I think I'm on 606. If I look at transformers, I am. So I am writing a compiler in Haskell for a made-up language, which is based on Rust. So the syntax is a subset of Rust, but a very, very small subset. There's so many features of the language I'm not supporting, like traits, for instance. That's not part of it. And the reason why I am using such a small subset of Rust is because my target is not a binary. My goal is not to generate a program. My goal is to compile to an esoteric language, and specifically Piètre. And Piètre is a esoteric language in which the source code is an image. So we're taking Rust-like code and we are generating images in the output. This is a small example. I am far from done. We have the parser working, so I am able to take like Rust-like code and pass that into an AST. And at the end of the process of the pipeline, given some bytecode, I am able to generate an image that maps to this set of instructions, of Piètre instructions. I am missing all of the middle, as in how do I go from the past AST to the bytecode? That's the part I'm working on at the moment. My goal is to try to take this as seriously as possible, as if it were. That's the whole thing. It's like it's for fun. I've made like 12 years ago now an extremely small thing, like just the bytecode part, basically, as in give a list of Piètre instructions, generate an image, and I thought it was fun. And I wanted to redo it properly, but this time try to make it somewhat educational. And as a result, this whole process, this whole journey, I am like approaching it as seriously as I would a real compiler. I guess this is a real compiler, but you know what I mean. A serious compiler. So I've been using Alex and Happy, the parser generators for Haskell, which has been a pain. But because those are standard tools that go in the language, I'm tempted at this point to just rewrite with megaparsec, but I have a parser that works and I don't want to add more. But I've had to make concessions on the syntax because of limitations of Happy, and that is a bit annoying. And I have the bytecode part working. So now I'm doing the analysis, name resolving, type checking phase. The output of the IR I'm going to use, since again, I'm trying to take this project as seriously as I can, I'm going to use an IR based on the LLVM IR. Again, so much simpler than the real thing, but still the idea of trying to do something that like uses state-of-the-art real things, like a strict single assignment IR. And the side project will be, of course, to convert our IR into LLVM IR to then be able to compile an actual binary out of our Rust-like thing to compare with the interpreter of Piètre, basically. So this image was generated purely from bytecode, so not from an actual Rust-like file, but from like a manually written list of basic instructions. But it shows the rough structure of the Piètre files, where every function in the resulting binary will be one of those columns, basically. And you can see the entry points here of the different go-to labels, basically, of a function. And here are the exit things of the function. And at the top here is the strip that does, given an address which is at the top of the stack, does the redirection in the image to point to the correct label. And this is basically, is this one or is 2 less or equal than the thing? If yes, then we must go to address 1 here or address 2 here. If no, subtract 2, go to the next thing. And so we can just compose images by aligning functions like this. This evening, what I've done is mostly rewriting I've made some changes to the AST. Specifically, the way I had done the different phases of the AST, I wasn't happy with. I've rewritten this. And I've started writing the rough structure of the analysis phase, which is going to do name resolving, type checking, simplification, desugaring, that kind of stuff, and maybe some inlining as well, depending on how I want to approach this. And given that I've been streaming for 4 hours, I think as soon as I've managed to figure out what this error means, I'm just going to be in it for the evening. But yeah, the whole point is like, make a fun project with an esoteric language that I love, but take it as seriously as I would a real compiler for a real language. I've written, if you go to the GitHub, I've written like a very rough spec, but to try to highlight, this is the language we're targeting, this is what we're trying to make. And I have a short a 10-minute video introduction on YouTube of like, this is what the project is about. But yeah, that's it. That's the project. And now I'm trying to figure out why it believes that this RWST thing should have a reader instance for tuple, which is completely wrong. How did I mess that up? I am guessing that, oh yeah, I was trying to see, is it's back, perfect. Yes, I am using the wrong operator, that's why. Which I think is instead a tilde here. There we go. Okay, new errors. Unused matches. That's perfect. That's just all of the arguments I have named here that I have left undefined because I didn't want to actually start writing all of this evening because it is getting late. Since it's not going to compile if I don't use them, I'm going to comment this all out. Excuse me. And check that this compiles without this. It doesn't. What's wrong? Oh, because of course the instance is missing. Okay. Yeah, I think I'm just gonna comment this all out just because I want to run the tests for the evening. And next time we uncomment this and we... Yeah, I'm ending in a few minutes. I'm just making sure that what I've written here compiles, that the tests still pass. I commit this, and I think I'm done for the evening. Because it's been 5 hours and a half. It's been a while. Oh, of course. Uncommenting everything. Okay. No, I'm gonna keep it. And that just means that every time I have a match that is a name, I'm just gonna match it with an underscore. So that the compiler leaves me in peace for not using the variable. Yeah, nice to meet you as well. I hope you had fun. Yeah, I'm streaming. I'm trying to stick to 2 streams a week, and Tuesday and Thursdays at 8 p.m. Irish time. But I will announce on Blue Sky and Mastodon if I can't make one of the streams. But yeah, in theory, if all goes well, if everything goes fine, next stream is... Today's Thursday, so next Tuesday. And hopefully next time we make actual progress on the analysis rather than just doing the rough skeleton and not doing more than that. Oh yeah, and I forgot to mention, I will announce it on socials. I have not done that yet. I have started a second YouTube channel in which I have started to upload all of the previous streams. I am only missing 2 that I forgot to download in time. The very first one, but since I had a bunch of hardware issues, nothing of value is lost. But sadly, I'm missing the 1st of April stream in which I found a bug in Alex. That was extremely fun, and I forgot. I then spent a week like fixing a 7-year-old bug in Alex, and I completely forgot to download the stream. So that is missing. Okay, but yeah, see you on Tuesday. And there we go. It now all compiles. The tests we have that are still very basic are still passing, which is better than nothing. I mean, our tests are basic, but they found an ambiguity in the syntax that I've had to fix by changing the syntax of the language. So, not too bad. I probably want to do this like Let me put it in a way that's visible on stream. Something like that. What have we done this evening? This is not part of the changes I want to commit. I think the first thing is I can commit with location on its own. It being added doesn't change anything. Sorry, I was saying my streams are Tuesday and Thursdays, and I'll announce on social media if I can't make one of the streams. So, see you on Tuesday, probably. Let's go incremental commits. What can I commit incrementally? I think most changes are going to be pretty big. I can probably make the change to the token and to the Lexa. Actually, I'm going to need to make a change. This needs to be in the previous commit. There we go. Now, I can make the change to the Lexa, where we add a new thing, to the tokens, where we add a new token, and to the parser. So I'm going to just commit that change in isolation, which is the fix of the fix for... See ya, thank you again. For the ambiguous syntax, which was this. It is this very line that I'm going to commit. Did I commit too much? Nope, perfect. And I just need to find the other... There we go, this line. Oh, that's even worse. I want to only commit partially this line. I want to only commit the change, which is adding... Can I do that? I don't think this is gonna let me actually only stage this. I don't think it's good to this point. Yeah, no, it's not. So if I want to make this an incremental commit, I should do it at the end. Ah, that's annoying. I've modified both. The file has been modified twice. I guess I could commit this and then stage everything and edit this commit to only contain the change to this. I think I'm gonna do that. Because that's just adding the token, changing the Lexa and the parser here, but nothing else has to change. Yeah, I'm going to do that. So I'm going to write this commit on its own and then edit it manually afterwards by doing a rebase. Or could I? I could do something even smarter. I can go right now to parser.y. Go here, replace this line with the old line. add the at here. So I have the old line in this file. Where is it? Where is it? I don't see it. It's somewhere in there. There we go. I can stage that. And now the stage version here that I'm going to commit should only contain there we go. It is a version that only adds the at symbol. So I can commit this in isolation. Fix last ambiguity in language. This is ugly and annoying. We are not able to distinguish between an expression that ends with an identifier and is followed by the opening brace of a block, and a struct expression, which is the name, the type name, an identifier, followed by an opening brace. As a result, that being said, can this ever happen? No, but even if it cannot, I will never be able. I don't have a generic rule. Yeah. As a result, we can't distinguish between the two. Well, wait, no. That's maybe the solution, actually. Because the only problem with this, typing the commit message and figuring it out, the problem with this was in an if block, if an if block and the end of the expression of an if block is an identifier followed by braces, we would consider that a struct expression. I could perhaps change that and say, no, I think it's fine. Just because we're never gonna have a struct expression in an if block, right? That's never something. Oh, but no, but if I do if foo with foo being a boolean, yeah, it wouldn't pass. No, this is okay. We can't distinguish between the two, and something like if foo open braces bar would be passed as creating a struct foo in the condition of the if. This could be fixed by rewriting everything with megaparsec. For now, we simply introduce a new language element, the at operator, which is only used for struct initialization. This fixes the last remaining shift reduce conflict. There we go. So now this has been committed in isolation. I can revert this to be the correct one so that I can moving forward, I can actually put the proper one in the commit. Now, what do I do next? What do I commit next of the things we have done this evening? Analysis definitely last. I think I'm just gonna bundle all of the changes to the AST as one big commit that gets rid of the entirety of the weird extension types, which is always good. Like, that's a big block of red. To go with this, I will need the changes in parsing. I will need all of the changes in the parser. Those are fine, I don't need them. I'll need the changes in arbitrary. I'm bundling a few of the changes we've made to like non-empty and everything. I think that's fine. And the tests as well. Bench extension types for each possible constructor. We annotate the most important part of the tree, declarations, statement, and expressions. Furthermore, this commit expands the test suite and fixes a few remaining errors, such as using non-empty for struct initialization. Okay. And now what's left is name analysis. Oh, yeah, actually that file doesn't need to be there. First skeleton, first draft of the analysis phase. There we go. That's all committed. Let's go back here. Let's check that this all compiles after my mishaps. There we go. And the tests are still passing. Push that to GitHub. And there we go. And that's gonna be it for me this evening. Thank you for tuning in. I'll see you all on Tuesday for the start of the actual analysis phase, where we're gonna start actually doing checks and validation and report warnings and throw errors and start having fun. In the meantime, have a good weekend, everyone, and I'll see you all on Tuesday.